All right. Hi, everyone. Thanks for joining our Catching Up with Maya launch stream. I'm Jennifer Waters, Industry Marketing for Film and TV at Autodesk. And today I am joined by the Maya product team who are going through some exciting new updates in Maya. We will be recording the stream and it will be posted on YouTube shortly after the webinar is finished. Like most of the world, our entire team is working from home. So if there are any technical difficulties or connection issues, please bear with us. All right, let's run through the agenda. We have a jam-packed schedule today with two very special guests from Luma Pictures and ILM. First up, product manager Stephen Rosell will give you a quick intro on the latest updates to Maya. Next, Will Telford, senior product owner of USD and rigging, will give you an overview of Maya and USD, and will be joined by Paul Molodewicz from Luma Pictures. Will Telford would then walk through Maya's exciting new rigging updates. Next up, Mark Tanner, senior product owner, and Meghna Gupte, senior user experience designer, will go through the many animation updates, followed by an interview with ILM's Jean-Denis Haas. Lastly, Stephen will give you a peek at the community-inspired modeling updates we've added. We'll then wrap it up with a live Q&A at the end. Throughout the presentation, feel free to submit any questions you have in the Q&A panel at the bottom of the screen. We'll either save your question for the live Q&A or answer it right in the chat. And with that, I'll let Stephen kick it off.
All right, thanks, Jennifer. Let me share my screen real quick. All right, so let's get started. Welcome to the live stream, Catch Up with Maya, and that's what we're going to do today. We're going to catch you up on all the latest updates. Of course, you've probably heard by now that we announced Maya 2022 yesterday. There's a ton of stuff to talk about, actually more stuff to talk about than we have time. So we're gonna pack this just full of information. Quick introduction. My name is Stephen Rosell. I'm a product manager on the Maya team. I've been working as a product manager on the Maya team for about a year and a half, a little over. But my history with Maya goes way back beyond that. I won't say how many years because I don't really want to date myself, but I have a long history working with Maya, a former artist, former 3D artist. Still dabble with it, still like to get my hands dirty. For the agenda today, as Jennifer said, we've got a lot to talk about here around USD, which Will is going to cover, Will Telford, rigging, animation, modeling. We've got really a little bit of something for everybody. This is one of those releases where everybody is going to find something of interest. I've seen many Maya releases over the years, and this is one of the beefier releases I've seen in a long time, just in terms of the breadth of the features and the depth of those features. So before we get into the kind of the meat of the presentations, I do want to touch on a few specific things. One is the update to Bifrost. So we're not actually going to be covering Bifrost in depth in this live stream, but there have been a number of changes pretty recently with Bifrost. We released a pretty major update of Bifrost back with the Maya 2020.4 update, which was back in December timeframe, and we've actually added an incremental update since then. We've included a lot of new functionality, some cool stuff around world building with some scattering and some instancing compounds, support for Maya curves, which you didn't have before, shape nodes that allows for tighter integration with the Maya graph into the Bifrost graph. And then lots of stuff around effects. So volume improvements, volumetric improvements, cloth solve improvements, as well as some aero or atmospheric solver improvements. So a bunch of stuff. Again, we're not going to dive into the details here, but there are other sources. If you go to the area, we've got a blog post that covers all of this in pretty great detail. One thing I want to point out is Bifrost is actually updated very frequently. So with every major release of Maya, or even with every update of Maya, we do of course include the latest version of Bifrost, but we update Bifrost kind of in its own cycle. So we've had numerous updates, well over a dozen updates since the original inception of Bifrost. We introduced Bifrost, I guess, probably about a year and a half ago. I think it was originally an update to 2019. And then we quickly added a new version of that to Maya 2020. And then we had 3 major updates over the course of 2020. And then lots of incremental updates. Some of those are feature rich, some of those are performance tuning, some of those are usability improvements, some of those are just stability improvements. But the main point is we're iterating very quickly and very frequently on Bifrost. So one other thing I want to talk about is Arnold integration. So with this release of Maya, we are integrating Arnold 6.2. We're not going to have a specific session on Arnold, but I just wanted to point out that there is some cool new stuff on the Arnold front for those of you that are interested in rendering. One of the areas we focused on is post-processing with Light Mixer and Bloom and updates to the denoisers. Of course, we introduced Arnold GPU about a year ago, and that was the first kind of incarnation of Arnold GPU, but we've continued to iterate on that as well. So we've expanded the Arnold GPU toolset. We've added shadow linking, shadow groups, and then lastly, of course, Will's going to dive into USD, but one thing I want to point out is that there is USD support in Arnold as well. So a few things. Oh, and then of course, just to reiterate the message, this is kind of a similar story to Bifrost. We update Arnold very frequently. So even though Maya, 2022 is going to come out with Arnold 6.2, we'll continue to update Arnold incrementally and frequently, kind of independently of the regular Maya releases, and then we'll roll that new functionality into the next Maya release, of course. So Python 3 is a big ticket item in Maya 2022. So for anybody that's doing any scripting or anybody that's working on pipeline tools, obviously this is a big deal. The entire industry has to move towards Python 3. As many of you know, Python 2.x is essentially being sunsetted, it's being retired. And so in Maya 2022, we now default to Python 3. So when you boot it up for the first time, it's going to default to Python 3, allowing you to move forward. But we, of course, realize that some people are not going to be ready to move forward. It's a big kind of daunting undertaking. If you have a lot of complexity in your pipeline and you've built a lot of tools, you may not be ready to move yet. So we're not going to force your hand. We're not going to make you move until you're really ready. So with this release, we're actually making it an opt-in, or you could say an opt-out, basically, where there is a startup switch. So if you want to work with Python 3 and you're ready to move forward, great, we're going to support you. But if you're not ready to move forward, we will still support your kind of old pipeline tools that are built around Python 2.x. So again, that's a startup switch of environment variable or a flag, depending on how you want to set it up. So one other thing I want to talk about is the streamlined startup experience. And this is something that, it seems a bit superficial at first, but it actually really has a big impact on your day, especially when you're booting Maya multiple times. So one of the main things we've done is we've actually just improved the boot time. So when you boot Maya, you'll notice a significant performance improvement just in terms of like actually opening Maya and getting started. The other thing that kind of flies under the radar here is that Maya no longer steals focus. So in the past, like you'd boot Maya and then you'd go to Slack or you'd go to Outlook and you start typing a message, and then Maya would start to steal focus every time you try to do something else. So we've eliminated that problem. That was a huge user complaint. We fixed that. So now you can boot Maya, you can go to Slack, you can type a message, and then Maya will be there waiting for you when you get back without interrupting whatever else you're doing. We've also made the output window optional. A lot of people don't need it. A lot of people don't use it. It just cluttered up the desktop. So we've made that optional. You don't have to boot it up, or rather it doesn't have to open up when you boot. But if you need it after the fact, you can turn it on if you want it. And then lastly, we've modernized the splash screen. And this, again, feels superficial, but it actually is useful because now you actually get a visual kind of representation of where you are in the boot process. So you'll see here in this image, like as soon as you boot it up, it lets you know, okay, I'm verifying the license. And then now I'm loading Bifrost. And then now I'm loading USD. So as you're booting Maya, it kind of tells you where you are in the boot process. And what you could do is you could actually use this to kind of self-diagnose your boot time. Oftentimes people will load a bunch of plugins, like third-party plugins, and they kind of forget about them sometimes. That can actually be a big bottleneck in the boot time. So what this does is it shows you where you are in the boot process. So if you have, plugin X that is taking a long time to load, if you don't need that all the time, you could just check that off and not load it, and then just load it on demand as you need it. And this is a nice little visual way of just giving you some of that information about what's happening in the background. But again, aside from all of this, the boot time in general is significantly faster. So that first time you install Maya 2020, pay attention to how quickly that loads. So without further ado, we're going to dive into the meat of the live stream. And again, we're going to kick it off with USD. I'm going to pass it off to my friend Will Telford, who's going to do a real deep dive into USD and the integration there and the native aspect of that. He'll get into rigging as well, and then we'll hand that off to Mark Tanner, who's going to cover animation. Then I'll come back at the end and we'll talk about some cool new modeling features that we've added. So without further ado, I'm going to hand it off to Will.
All right, thank you, Stephen. So hopefully, is my screen sharing currently? Can you see my mouse on this screen? Awesome, we're ready to go. Well, this is a fantastic turnout. I'm really excited to see you all here. There's a lot to cover in terms of what's new in Maya. Stephen kind of gave you a preview of all that. I'm going to start out with Maya USD. So Maya USD is brand new for Maya 2022. It's actually an open source plugin that we've been developing for the last few years in partnership with a lot of studios. So we'll go into the functionality of what you're getting with that plugin and what's available to you now. Real quick, y'all heard a few people mention my name, my title. I'm a product owner. I'm the product owner for both USD and rigging. I come from a background of visual effects for the most part. Spent a lot of time at Rhythm and Hue Studios. I spent a little time in gaming with Blizzard Entertainment. And so that's the production experience I bring to this. And this tool is the type of tool that definitely could make all those production experiences run a lot smoother. So I'm gonna give a bit of an overview. The first section that I'm gonna talk about is just a single slide. It's just a little background on what USD itself is, in case you're not familiar with USD. If you would like more detailed information on what USD itself is, there are prior presentations we've given where we've gone into a lot of detail about USD itself. But today we're really gonna focus on its integration within Maya. But I will briefly talk about what USD is. So USD is an open source technology that Pixar released in 2016. And it's, at the risk of reading a slide here, it's an extensible common language, and it's a composition engine for 3D data. And there's a lot of problems in visual effects and gaming and animation where you have large data sets that you're having to manage, you're having to collaborate on these things. You're wanting to edit this data and move it around. And this USD technology really helps solve all those problems together. At its most basic, a lot of people look at USD and think that it's just a geometry caching format. They might think that it's just a drop-in replacement for Alembic, or it's a replacement for FBX. And in a lot of ways, it can replace those, but there's a lot more going on there that it's capable of beyond what those other technologies can do. So yes, it can represent geometry caches, but that's just the tip of the iceberg for USD. One of the more powerful features of it is the fact that it has a system of non-destructive sparse overrides, which it implements through something it calls composition arcs. This is a compositor for 3D data. So you can have a bunch of different ways of authoring opinions about data, and those opinions are all resolved down to compose a final scene graph for you. So of the types of composition arcs, we have file references and we have payloads, we have variants, we also have just basic layers, sublayers. And at the end, all of that is composed together and produces an extremely lightweight, highly optimized scene graph. Sorry, pop open my chat here, make sure I'm not missing any messages that might come my way. Okay, so that's just a really brief idea of what USD itself is. Again, Pixar has amazing documentation on USD itself. So if you just Google Pixar USD, they maintain a site that has really thorough documentation, technical documentation, user documentation. It has great glossaries that really gives you an understanding of what USD provides. And now we'll go into the Maya implementation of that. So USD and Maya. The first thing that we wanted to be able to do is bring USD data into Maya. Now, we're bringing this in a different way than we've brought data in the past. It's not the same way you might bring in, say, an OBJ or something like that. USD data is brought in and maintained in memory as USD data. It remains USD data. And so we wanted to be able to see that data in Maya. The first step would be, if you have USD data in your pipeline, you need to be able to visualize this data in Maya when you're using it. And there's three main places you want to be able to visualize that data. You want to be able to visualize it in the outliner, where you want to see the scene hierarchy and representation of it. You want to be able to visualize it in the viewport, and you want to be able to visualize it in the attribute editor. So I'll start with the outliner a bit and just talk some about what you're seeing here. So this is just a close-up of our current outliner. And what you see here is you see two different data models. You have the native Maya data model, but you also have the USD data model that's sitting right alongside of it. And what we want to do in the outliner is give you an indication of whether you were looking at the USD data model or the Maya data model. And you can see that up here, these are Maya cameras. So these cameras are represented by Maya transforms. And what you'll see down the side here is you see the familiar expansion boxes with the little plus in them. They're gray. And then you get down to a Maya transform, and then you get down to the proxy shape. The proxy shape is a custom shape node that holds all of the USD data that you want to see. So the proxy shape is a Maya node, but everything under it does not exist as a Maya node. These are simply these are simply pieces of USD data. These are USD prims, what you see here. And so the way we've shown you when you're looking at Maya data and USD data is we have these square boxes and this gray color when you're dealing with Maya data. And when you're dealing with non-Maya data, what you're going to see is these diamonds, and you see a different color representing the data branches that are the non-Maya data models. And if you don't like these colors, both of these colors are now adjustable through Maya's color options, so you can adjust that. Now, we talked a bit about USD having non-destructive edits in it. And so we've done our best to show that in this editor as well. So if you have visibility, an item will be grayed out, just like a Maya item is. So you can see here this item called North Group is grayed out because it's invisible. But you'll see right below it, you'll see something that's grayed out with a strike through it. Well, that's showing that this prim happens to be deactivated. And what a deactivation is in USD, it's a non-destructive deletion. So you can delete this item, but it's still there. It just acts as if it's deleted. So that's why we call it non-destructive, because it can always be brought back. Now, if you have a USD scene that has a tremendous amount of deleted items in it, deactivated items in it, and you don't want to see them littering your outliner, you can come up into the display menu and you can pop that open and you can filter out inactive prims. So it won't show you all those deactivated ones, but you can always toggle that back on so you can get to those prims and reactivate them so you can see them. Along with that, you see the data type. So icons are showing you the data type. So this arch group, this is a USD prim that is of type transform. So it uses the same icon as Maya's transform icon. So you can see data model, you can see data type, and then we also talked about those composition arcs that USD has. And some composition arcs live on individual prims. Some apply to the whole stage, which is USD in its representation in memory, its container in memory. But a lot of composition arcs just apply to individual prims. And so when there's a composition arc on a prim, like say a reference or a payload or a variant, you'll see this badge here. So here we see this little arc badge, and this lets us know that kitchen table has a composition arc in it. In this case, it's a reference. So kitchen table has been referenced onto this prim. Down below it, you'll see that chair B1 has a composition arc, but it shows the V because it's a variant. And later I'll show you that you can right click on that variant and choose which variant that you're displaying when you're editing this data. So this is visualizing the data in USD. So I'll show you one of the most important things is showing this data in the viewport. So what you're seeing here, this is entirely USD data in the viewport. And you'll see that USD data is supported through our draw styles in VP2. So we can draw them as bounding box, we can smooth shade these things. I just walked through a few of these so that you can get an idea of the draw styles that are supported on USD. And keep in mind, this is not my data we're looking at, which is fantastic because it's very efficient, fast data. Here you can see that screen space ambient occlusion is supported. I think I'll go here and I turn back on wireframe overshaded, so you can see that it's aliased a bit. And if we go turn on the hardware anti-aliasing, that cleans it up. So anti-aliasing is supported. All these different draw styles are supported. You'll see that lights are supported. Now this is a Maya light on a USD object, and you can see that shadows are cast. And you can cast shadows from USD objects to Maya objects from Maya. They can live in the viewport together. Here you'll see that we marquee select a Maya light and the mesh, and we decide we don't want the meshes. So we turn off the pick masks, and turning off the mesh pick mask is respected by the USD selection. We can select USD data right in the viewport. We can frame it, and we can work with it just like it's Maya data. So that's our goal here, is to make sure that your interaction with this data is as seamless as if it were Maya data. And just at the end here, I turn on the Maya representation of this. So you can see what the Maya version, which is on the left, and the USD version on the right look like together in the viewport. So very powerful, very fast. and like I said, fast. That's one of the focuses. So with USD, Pixar shipped a tool called USD View, which is a great viewer of USD data. And it's very fast. It shows off how fast USD is and how performant it is. So we've been using that as a benchmark as we've enabled USD support through VP2. So I wanted to show you that here. This is a point instance example where I'm going to create this point instance example. It's 6,000 objects from the Pixar kitchen scene. You see how quickly they load. When I switch to render, it's instantaneous. So we'll swap this out for a higher resolution geometry. We'll go for 138,000 of these things. You'll notice the proxy version loads instantly. When I switch it to the render version, I think we have about a 2-second load time to load 138,000 of these objects as point instances. And then you can see the tumble performance and playback speed when we're dealing with such heavy geometry. So extremely, extremely fast. Now, this is a bit of a contrived example. So I will show you a more production-friendly example. This is some geometry, and this geometry came from Gaia, and the trees here come from SpeedTree. But these are about 50,000 poly trees, and there's several 100,000 trees on this. And watch how fast this loads when you load this set. So pretty fast to get in and working with production level assets. And that's one of the primary goals of USD, is to make sure you have this fast interaction and not take the overhead of the Maya data model when you don't need to bear the overhead of the Maya data model. Okay, so we talked a bit about this USD data model that's new to Maya, and you're already familiar with Maya and all the workflows it has. Maya is used in all stages of production pipelines, and it's been around for 20 years. So there are 20 years of workflows built up across all different stages of the pipeline. So a lot of functionality. And then we have this new data model that introduces even newer concepts, and we want it to work together seamlessly. So the surface area of the intersection of those two is huge. So we needed to take a slice of that and tackle a slice that we felt would deliver a lot of value to you and get you going. And I think what we settled on is that assembly and layout really was the workflows that we wanted to target first up, because we felt those could really leverage the power of USD the best right now. So as we define USD, as we define assembly and layout, we kind of break it up into these simple functions. I think this is an oversimplification of assembly and layout, but it's a great way to kind of wrap your head around what our goals were here. So the first section of assembly and layout would be the ability to create a model, right? You want to be able to work like you always have in Maya. You want to generate models from your modeling department, and you want to write those out, but you want to create a library of USD assets. So you want to be able to take a Maya model, and you want to be able to convert it to USD data on disk that can be consumed by your pipeline. So that's the creating a model phase, and we'll go into that. The next would be to create a set. So once you've got a disk full of these USD assets, you need to be able to bring them into a set. You need to be able to assemble them and aggregate these things into larger pieces using USD. And that's really how we've kind of defined the creating a set aspect of it. And then finally, you need to be able to edit a set. And editing a set means that you want to be able to create a layer shot structure that your pipeline might use, but you also want to be able to author those non-destructive edits on that USD data that we talked about. So I'll go ahead and drill into that. So the first one is creating a model. And like we talked about, creating a model is about data translation. So I mentioned earlier when we had VP2 that we would bring USD data into memory as USD and keep it as USD data. But there's actually two ways to get USD data into Maya. One way is through data translation. What that means is you have USD data on disk, and you go and you import it, just like you're importing an OBJ. But once you've imported it, it exists only as Maya data. It's thrown away any knowledge of the USD data, and it exists as Maya data. And the same thing round tripping that. If you're in Maya, you've created something in Maya with traditional Maya tools, Maya meshes, and you want to generate USD, you need to translate that through an export process to USD. So this is the second way to get USD data into Maya. It doesn't leverage as much of USD's power as bringing the stage in and keeping it in memory does, but it is useful for your pipeline because all your modeling tools are on Maya data. So I'll show you what that import process looks like. It looks just like importing any other, importing and exporting any other data. So here I am looking at a Maya teapot, and I'm making an edit to this teapot. I'll go ahead and go through a traditional file export, but instead of another data type, I will choose this USD export. And you'll see I have several options about what gets exported to USD with this, how I want to interpret materials that go out, and we'll export that. And then I'll pop it open in USD View, which is Pixar's preview tool, and you can see that it looks the same. So USD is a fantastic interchange format and a very fast interchange format. And you see that we have the same look in the viewport there. So now I'm going to bring that teapot I exported back in as a stage just for comparison's sake. So now you're going to see the side-by-side, the Maya data on one side and the USD data on the other. So these are the two data models sitting next to each other in the viewport together. And you can see that they're indistinguishable. So this is a fantastic way to generate and work with these models. Let me pop on to the next one. Okay, so the inverse of that is being able to import a model, right? If you have USD data on disk, but you need to make some mesh edits to it, or you need to work on the model, you do have the ability to re-import that back into Maya. So here you'll see I just go through a file import. I'll select the asset on disk that we've already modified. And when I go to import this, I'm going to pause this when I get here. So one of the things that this does is it brings up what we call hierarchy view. And this is a fantastic tool for import because it lets you set the state of your USD scene before you import it. USD data is meant to hold very, very, very large data sets. So you could have a very large data set here. And if you convert that entire data set to Maya data, there might be some overhead you incur that you don't want to incur. So yes, if you only want to work on a piece of a set, you could import the whole thing and translate the whole thing and then in Maya prune it back down. But this interface lets you go ahead and get a preview of the data before you bring it in and kind of set the state and say, I want to bring this object in or not that object, or I want to set this object to a particular variant. And then it'll import just that state of USD. And that'll make sure that you don't end up translating data or taking the hit for translating data that you really didn't want to work with in the first place. And if you want to bring the whole USD data in, you don't have to go into hierarchy view. You can just reset it back to the whole data set and it'll bring in the whole data set. We have a teapot here. We want to bring the whole thing in. So we'll go ahead and bring that in. And then here I just bring it back in as a stage so you can see again the Maya data next to the USD data. And you can see that that is another lossless round trip there. So very powerful. And so using that process, we now have been able to create a library of assets on disk. We have a folder that's just full of USD assets that represent this kitchen we want to build. So now we want to build this kitchen. And what we can do with USD is USD has a layer structure to it. And there's two types of layers. One is a file backed layer, which means there's a file on disk. The other one is called an anonymous layer, which means it only exists in memory. And so we've enabled workflows to let you work with anonymous layers so that you don't have to go create a bunch of files on disk until you're ready to. So that's the process we're going to use here is we'll start with an anonymous layer. So I'll go into the My Create menu. I will create a stage from the new layer. And then I'm going to add a transform to it. And I'll rename it. And you notice that I'm working with USD data natively. There's no Maya data here. And I'm able to rename these things in the outliner. I'm able to duplicate these things. I'm able to group them. And then here I'm creating a def, and then I'll right click on it and I'll add a composition art to it called a reference. And now I'm going to bring in walls. I'll do this 2 more times to bring in a floor and counters. But you can see that we've introduced the new concepts of USD, like USD references and things like that in anonymous layers. But we have also supported traditional Maya workflows in terms of the outliner support with hotkeys and renaming and duplicating and things along those lines. So it lets you keep you don't have to learn a new workflow when you're working with USD data. Let's get past this. Okay, so now we've created the set, but like I said, it exists only in memory. This doesn't exist on disk yet. So we want to get this out to disk. So we can pop open this layer editor, which lets you see the sublayer stack of USD. You can get that from the outliner, or you can go into the Windows general menu and launch it. It's proxy shape specific. So each shape represents a different stage. So you can switch between different stages if you have multiple stages. You can double click the root layer, the anonymous layer, and you give it a file name. And now it's going to write it out as the name I gave it, which is kitchen.usda. Now this is saved out as USD data. So that was pretty simple. We assembled this thing, and now we've got a set that lives on disk. So next is being able to edit these sets. And if you remember earlier, I said there's going to be two main pieces to edit a set. One is to build up the basic shot structure you want. So this is a very quick example. So watch, don't blink here. I add 6 sublayers. I structure the 6 sublayers, and then I hit save the stage, and I bulk save it. I give each layer its own file name. And when I'm done, I'll have a shot structure that's broken out by sequence level work and shot level work between animation and effects and dressing and layout. And so I was able to create that structure rather quickly. That structure is a bit of an arbitrary structure. You can use whatever's best practices in your own pipeline. That structure was actually based on that Pixar documentation I told you about. If you go to the Pixar USD documentation and you go into their glossary and you look at the sublayer example, they lay out that particular shot structure with those names. So I just showed you how you can create that example from the Pixar documentation very quickly right through the UI. Okay, so now that we've got our shot structure we want to work with, now we want to bring the kitchen we've created back into that shot. So here's where we're going to get into a lot of the non-destructive overrides. So what we want to do is in that sublayer stack we created, we're going to go to that weakest layer. And we're going to target that layer to say anything we edit is going to be written to this layer. So here you'll see I target the weakest layer in the layer editor by just clicking this circle. And now everything's going to be written to the sequence dressing. So I'll add a new prim here. I'll add the reference. I'll rename it to kitchen set, and I'll reference in the kitchen set we created earlier. And now this shot structure is going to bring the kitchen set in on this weak layer. And so that's what's going to enable non-destructive editing. So what we can do next, after we get through this one, I'm just going to go ahead and save it to disk to make sure the stage is saved. So these changes persist. The next thing we want to do is now we want to actually get in and edit this stuff. You know, we've talked about how we wanted all this to feel very natural and native within Maya, but we haven't shown any editing of USD data. We've just shown converting and viewing. Now what we'll do is we'll have the user target the next strongest layer, the layer right above the one that we brought the kitchen set in on. And now all of our edits will be written to that layer. And I'll show you some of the edits we can do. So here we go. We'll target the sequence layout layer. So now all of our edits will go there. So we're going to move the teapot around on the counter. It's not where the director wants it. So we need to move it around. We're able to do that. And it's authoring that edit. Just the translation is the only thing that's being written to the sequence layout layer, which is one of the benefits of USD. We're able to use point snapping. We can point snap to and from USD data in the viewport. Let's see, I'll show you a few other things here. I show you that the attribute editor isn't just there for looks. It's also writable, so you can edit the attributes right there, and those values are being authored to that layer that we have selected. Sorry, my edits lifted it off the counter, so I had to snap it back down to the counter because nobody wants a floating teapot. So then there's the idea of being able to select by kind. So there's a metadata that lives on each USD prim that's called kind. So you can specify the intent of a certain object. So when we select in the viewport, it's going to give us the lowest level prim that we've selected, but we can set that kind to model or assembly. And what it'll do is whatever we select, it'll traverse up from there and select the entire assembly or select the model that prim's a member of. We also have the ability to save individual layers. So you can see in the layer editor, we can right click and save individual layers. We have the ability to here, I think, is this a clear or remove, I believe. I'm reverting to the file. So this will revert to the state of the USD as it is on disk. We can also come down and we can clear all opinions from this layer, which will return the teapot over to the stove. Along with that, I believe muting is next. So it'll show you how you can mute a layer, which is, oh wait, so sorry. We're gonna add a parent layer first so you can see the convenience function to create a new layer above you and parent yourself into it. And then I believe now we cover muting, here we go. So if I turn this mute button, what it does is it turns off the effect of the layer, but it keeps the edits around. And I can turn that back on and the edits get reapplied. So this is a big part of that non-destructive editing. One of the edits we could have made here is a delete. We could have deleted an object non-destructively and toggled this on and off. Through the script editor, you can debug these things. You can print the contents of a layer to the script editor, and you can see the only thing that exists on that layer is just the fact that we've moved the teapot to a new position. So it's extremely efficient and a great way to work. You just have to structure best practices around these tools. And that really encompasses all the assembly and layout workflows. One more thing I wanted to touch on with USD is constraints. So there are a lot of studios that we've been working with on this, and a tremendous number of them wanted to be able to depend USD data and Maya data on each other. And so what we did is, there in the current release, there aren't any workflows built around this, but through scripting, you can access and build these dependencies. And so we put that in there so that pipelines can put tooling around it and start using these dependencies where they need it. So I'll show a video of what that looks like. This is a Maya light in the scene. And this is a USD rescue boat here. And as I move the USD boat, you see the Maya light moves with it. And I can show you what that looks like in the node editor. There's just a DG level connection that pulls the matrix of the boat out of the proxy shape and drives it into the offset parent matrix for the spotlight. If you're not familiar, offset parent matrix is a new attribute that the rigging team introduced into Maya 2020 last year. That introduces just an arbitrary matrix into the transform stack. And you can use it for things like this. We were able to leverage it for USD to take this matrix out and drive the position of the spotlight while still being able to grab the spotlight and edit it, because that connection is not occupying the transformation channels. So the last thing I wanted to talk about is really the fact that this has been a collaboration, right? This is an open source project. The history of USD and Maya has been a bit fragmented. In 2016, when Pixar released USD, they also released some integrations to third-party packages, and one of those was to Maya. Now, the way Pixar works in their pipeline is Maya is in heavy use at the beginning of their pipeline, but they have proprietary software that they use in the middle stages of their pipeline for animation phases and things like that. So Pixar's plugin into Maya had a big emphasis on data translation, those import-export workflows we talked about towards the beginning of the assembly and layout section. And so that was fantastic. But when they open sourced that, other studios saw this and saw the value of it and started trying to adopt it in their pipelines. And one of the most well-known examples of that is Animal Logic, who went and built a tremendous amount of functionality around this plugin. And they forked the Pixar plugin, and eventually that fork got pretty far away from where the Pixar plugin is. And the emphasis of that plugin was around shot-based animation, because Animal Logic uses Maya throughout its entire production pipeline. And so they needed much better shot workflows that the Pixar plugin wasn't as well suited for, because Pixar didn't use those. So that's where their emphasis was. And they very kindly open sourced their project as well. And where that ended up was there were two very good plugins that did two very distinct jobs out there, and it was confusing a lot of users. And so we all came together. We did that along with Luma Pictures, who also had Maya to Hydra, which integrates the Hydra rendered delegates into the viewport and implements a Maya scene delegate to Hydra, and with Blue Sky Pictures. And we brought all that together under one repository and brought this to this one plugin that you're seeing here that has shipped with Maya 2022. Now, the great thing about this is open source. It's decoupled from Maya. It's a plugin. So, within the next few weeks, there's going to be an updated installer for the Maya USD plugin that's going to bring even more features. So we have the ability to keep dropping features, and you as users have the ability to engage with us and talk with us. I've put the website here, github.com/autodesk/Maya-USD. If you're not technical and you don't deal with code, don't let this scare you, the fact it's hosted on GitHub. There's a discussion board there where you can come and ask questions, and it doesn't matter whether you're a programmer or not. And the packages that we're going to be putting up here are going to be pre-compiled installers. It's just going to be where you're going to be able to go and download an updated version of Maya USD and be able to install that and run against Maya 2022. I will say, as a plugin, it also installs against Maya 2020. It installs against 2019. But a lot of the functionality I showed you depends on, I'm going to get a little bit technical here, but a lot of the functionality I showed you depends on new API that we call UFE, which stands for Universal Frontend, which is an abstraction layer between Maya's interface and the underlying data model. And so Maya 2019 and 2020 use UFE 1.0, whereas 2022 just shipped with UFE 2.0. There's a fall off in support of certain features as you move back into UFE 1.0. For example, the attribute editor is only in UFE 2.0. The right-click menu on the outliner, that's only in UFE 2.0. So if you use our plugin in versions before Maya 2022, it works, but expect some scaled back support for certain features. One nice thing is the entire import-export workflow does not depend on UFE at all. So that one works in every version of Maya that you can install it against. So that's really USD in a nutshell. I will go ahead and I think transition on into the rigging workflows. I don't know where we are in time. Maybe one of my companions could post a time check for me in the chat. But let me go ahead and move on to the rigging deck. Let's see here. Okay. Sorry for the radio silence for a moment. Okay. All right. So I'm good with time, it sounds like. And we're going to move on to the rigging tools. So apologies that I'm going to take two big sections right back to back. But this is, we're gonna pivot over into Maya's rigging tools, which right now don't have an overlap with USD. And I see some thanks going on in the chat. You're absolutely welcome. We're very excited about Maya USD and everything it's bringing to the table. USD is a fast-moving train, and it just adoption of it in the industry is really not a question of if for anybody's pipeline. It's really a question of when. So it's really nice to jump into this and familiarize yourself with it. If your studio hasn't adopted it yet, play with it. Let us know what you think. That GitHub forum is a fantastic place to put feature requests and understand where we are. And all development is in the open. We're not developing any features in the private. So if you see pull requests in there and you see us actively working on things, those are the things that are coming to the plugin. So engage with us. It's our first time as a team doing an open source project, and it's going really well. And we've gotten a lot of really meaningful contributions from all over the industry. So please join us there. Okay, so now with I'm gonna look over our attendees. Okay, I don't see, all right. We'll go on to the rigging section. So with rigging, well, I'll skip past this slide before I talk about that. It's another intro slide. For those of you that tuned in late to this talk that didn't catch the head in, this is who I am. This is what I do. Background in visual effects, 14 years at Rhythm and Hue Studio, a few years at Blizzard Entertainment, and a few years in a VR company. So this is the experiences I'm trying to bring to the table for the teams that we're working on here. Okay, so I want to talk a little bit about what the rigging goals have been. With Maya 2020, if you're familiar at all with that release, you started seeing us dip our toe into more procedural workflows. Things with the offset parent matrix, we're really looking on switching things from creation state, where when you create something in Maya, a bunch of data is cached away in an inaccessible way or in inconsistent ways, and move to something that is more rest state based, where you have your current state and your rest state. And if we go there, we have a lot more functionality that we can perform. Along with that proceduralism, we want a system that, with proceduralism implies that you can change your inputs and get a different result by running it through the same procedure effectively. And so a lot of Maya, because it's creation state based, it does a lot of things really well, but it's really not built to expect change, right? It kind of assumes that you've got a final model and you're doing your final work and you're not going to redo it, right? You don't want to start over and redo those things. And that's not realistic. That's not the real world. And so what that is forced a lot of studios in is every studio that's using Maya in their character pipeline is leveraging build scripts in some form or fashion. When they build a character, they're finding some way to capture that build process. So if the inputs change, they can replay that build process to get back to where they were and continue on. And there's a lot of inefficiencies to that. There's a lot of overhead and a lot of manual change that's going on. So a lot of the changes that we made is about expecting change and allowing for that change. And one way we want to do that, like I said, we hit transforms in 2020. We really want to hit the deformation and geometry side with 2022. And so a big part of that is supporting topological independence, right? Just because somebody splits a poly on a model doesn't mean that all my weighting information should be useless, or I shouldn't have to go clean that up in a meaningful way. And so I'm going to talk about some features that really help move us forward in that procedural direction. Okay, so the first one is a feature called component tags. That's a name that we settled on. It's not an existing name out there, so I'm gonna don't be surprised if you don't know what component tags are yet. I'll be telling you what component tags are. So component tags are effectively name sets of components that are stored on the shape itself. So right now, if you use a deformer and you create membership, you might be aware, if you looked at the node graph, that Maya creates a group ID, a group part, a deformer set, all these things to basically maintain a collection of components that the deformer is going to act on. In other ways, you might be used to Maya object sets, where you create a collection of objects and they all sit in this object set. So instead of dealing with those extra nodes and extra graph connections, what we're doing is we're saying the shape owns the components, so the shape can own the collection of components. So we're creating these named components on the shape itself. And I'll show you what that looks like on a character here. So this is a character that already has some component tags. Right in the attribute editor, you can expand the component tag widget, and you can see all the ones I've created: arms, arms lower, feet, and you see information about the component tags there, where they were injected in the history, how many components they have. I can click these icons are showing me whether they're face types, edge types, vert types, and I can click on these as I go through. Now, keep in mind that each component tag is homogeneous. It's all faces or all verts. But if you want one that's vert and another one's faces, you just create two different component tags. And I can get a little bit more into ways to leverage that. So that's what browsing existing component tags looks like on a character. This is just a close-up look of that widget. It also has some editing functionality in it. So if you were to right-click on one of these, you're going to see a menu that looks like this, where you can also select them. You can delete a tag, rename it. If you're going to edit those component tags, this is where you would come to replace them or clear them or add or remove from an existing set. Okay, so let's look at how you might create a component tag if you have a model that doesn't have any. So we're going to grab this guy's ear hole. At least I think that's an ear hole. We're going to grab that and we're going to throw it in a component tag. So I'm just going to use traditional Maya modeling tools. I select a face, I grow the selection, and now I come over to this widget. I add a component tag and I rename it. Pretty quick. So I called this thing ear. If I go back into it, you can see that ear exists. If I click on it, it's going to select ear. Another thing that you'll notice in the trend is we're trying to leverage the attribute editor a lot more. We're trying to put the tools you want at your fingertips, and the attribute editor is very context sensitive, and based on your selection, it's always there. So we wanted to make sure that we were putting this tool in a place where you didn't have to go dig for it or hunt for it to figure out where you manage these things. It's always right there in your attribute editor. So that's creating a component tag. So now I already alluded to this a bit, that component tags, one of their primary uses, so I'll stop. First thing is, component tags are nothing more than named collections of components. That's all they are. So anywhere where you need access to a name component collection, you can leverage these. But the first use case that we're using them for here is for deformation. And we're using them to replace group IDs, group parts, deformer sets. So I'm going to show you how you do that using what we call component tag expressions. And this is something that lives on the deformer itself. So I'm going to grab this character and I'm going to create a cluster. And it's a cluster on the entire character. So when I move it, you can see the entire character moves. But let's go and let's look at that cluster in the attribute editor. So we'll select that cluster and you'll see there's a component tag column there that has an expression in it. It had an asterisk in it, which meant it was a wildcard. It said, I'm going to act on all verts that come in, but I can give it a name. I can give it the name of a component tag that exists on this character. And right now I'll give it the name pouch. Now this is an expression. So I can actually say, give me pouch plus strap. So it's Boolean operations that you can perform. I can say pouch plus strap minus belt, and that one little piece pops back. This is also a place where to do certain Boolean operations, you can use casting. So you can cast a faces to verts or verts to edges. And we have the ability to expand that language for you to do common operations of being able to cast from one type to another, to convert from one selection type to another. So really powerful, and you can see how this starts to help with proceduralism, because before, when you create these deformers and you define a membership, it holds a fixed set list of components. And so if the incoming model changes, the component list is completely scrambled. With this one, as long as you pass out a model that has pouch defined or pouch and belt, which I had in there, as long as both those things were defined, this deformer will continue to work, and it will just act on the verts from that collection. Now, don't confuse this with weighting. There are two components to deformation. There is membership, which basically says, all right, which verts can this deformer act on? And then there's weighting that says, okay, based on that calculation, how much am I affecting each vert? So right now we're just talking about the membership side of that equation of what we can act on, not how much we're acting on it. Because I didn't define any weighting, we're acting on everything 100% at this point. So we haven't gotten into weighting here. We'll touch on that in a bit. So now let's talk about editing component tags. So if you have a component tag that you want to modify, we'll take the one we created earlier, the ear component tag, and we'll see that I left out a sliver on the edge. So I'm gonna go here. I'm gonna grab that sliver that was left out. That bothered me, so I wanted to complete that ring. Now, like I said earlier, you just right-click, go to components, and you can say replace. That entire selection now replace the existing component tag, and so now I've updated it. I have a clean component tag. The next thing is dynamic membership. So the way you've handled membership on deformers before is kind of a one-stop shop, and we've kind of broken the concept into two different places. Because these component tags can be reused, multiple deformers can point at the same component tag, whereas that wasn't really easy before when you had group IDs and group parts to say, oh, hey, I'm going to define a membership on one deformer and I want another deformer to use the same membership. That wasn't defined very well. So there's two sides of it. There's the consumption of the component tag where you define with component tag expressions, and then there's the component tags themselves. So you saw earlier when I was changing the expression that the membership was changing. So that was the deformer changing it. But the deformer will also update if somebody goes upstream to the mesh and edits the component tag itself. And so that's what I'm going to show you here. So this character is going to have a deformer on it that's going to smooth out almost its whole head here. So here I've smoothed out its entire head, and I want to isolate that to this nose section. So I'm going to give it an expression for the component tag nose, which is basically represents that. So I'll go back to this delta mush here, and I'm going to set it to nose, and you'll see that now that deformer is only affecting the nose, but it's affecting the nostrils. And so maybe I feel the nose group was a mistake and it shouldn't include the nostrils. Maybe that should be something else. So what I'm going to do is I'm going to go back to the existing model with the deformer still on, and I'm going to edit the nose group. And what you'll see is the deformer will update to respect the fact that those are no longer a part of the nose group. So that's a bit of a spoiler alert while you watch me grow this selection and turn it into a nostril that I'm going to go to the shape, and I'm going to pull these nostrils out of that nose component tag. So I'll right click on it and I'll remove those. And you notice that they jumped. That's because the deformer that's downstream that's using nose is no longer pointing at those because they're not a part of the nose anymore. So that's a great way. That's another way that you can affect membership. Now, keep in mind that change would affect every deformer that's using the nose group. That would pull the nostrils out for all of them, which is why sometimes you want to be dealing with component tag expressions. Other times you might decide you have the wrong component tags in your shape and you need to edit those directly. So let's look at some of the other effects of this. Okay, so let's look at some of the other effects of this. So one of the things we talked about is this is an alternate to the group ID group part section. So if you look at the graph here that's on top, you'll see a very complex graph, and that's the graph you get if you create, I think it's a cluster. If you create a single cluster, you get all of those nodes on a shape. And with the new component tags, your graph looks like the one on the bottom. This is not a node editor where we've hidden auxiliary nodes or anything like that. Those are all the nodes needed to deform this thing. So it simplifies your graphs, reduces the number of connections. And this goes back to the ability to edit rigs as opposed to having to replay a build script. With that graph on the top, you're not going to go hand edit that graph. That would be brutal. You're going to rebuild that graph from scratch. The one on the bottom, you have you're probably much more inclined to reorder some graph connections and play with that if you need to. So it does become easier. the file sizes get smaller, the evaluation gets faster, there's less plugs to pull on. So it's overall a win. So I'm going to show you that process right here. So here I'll create that deformer, that cluster deformer, and that's what it created, all of that stuff. Deformer, group ID, group part, deformer set. Not only that, it created a tweak node and its group ID, group part, and deformer set. So these settings I turned off intentionally to show you that, to show you the old way. But here in the options, you can say, hey, do we want to use component tags on creation or not? And you can also say, do I want to create tweak nodes or not? This way you can create tweak nodes on demand, because 90% of your pipeline is not leveraging the tweak node, yet they're littering your graph. So this is what it looks like when we turn those settings on. And so that second iteration is what Maya is set to by default. If you would like to create the old style node graph and go back to group IDs, group parts, and tweak nodes, you can go find that setting in the options menu. Another thing that's fantastic, that's just a creation time setting. These can coexist in the graph together. So if you have a character that has some component tags, some group IDs, you can do that. Just because a character has been built one way doesn't mean you can't create a deformer using the other methodology. So that's really just affects what happens at creation time. Both graphs are supported. Okay, and this shows you that. So conversion, here's a character and I just have one node I want to convert. Through this menu, I can right click and say convert to component tag. And it converted that skin cluster to component tag. Or I could say, I want to hit the whole scene. So I go to the plugin manager, I can load this convert to component tags plugin. And then there's the command down below with the scene flag. And it's going to take the whole scene and it's going to get rid of all group IDs, group parts, tweak nodes that it can. And there's a few flags in convert to component tags that you can pass it to kind of nuance the behavior you want. Cool. So that's how we use component tags for membership. There's another use of them. Remember I said they're just collections of sets. So there's other ways that we can use these things. So if y'all have been playing with the proximity wrap that shipped last year, what you may have noticed is in situations where you have a cage driving it on the mesh, you might have verts that bind to the wrong side of something. So that's where we've introduced using component tags with a feature called bind tags. So this is a low res cage that's going to drive this high res jacket. But you notice if we just do straight up proximity wrap with this, you're going to get shredding right down the middle because these verts don't know which side to bind to. But what we can do is we can define some component tags on each edge of the cage and the geometry. And we give them a specialized suffix. In this case, it's _prox. And then on the proximity wrap itself, we have the ability to check and say use bind tags, and we tell it what suffix to look for. And when we turn that on, things won't bind to the other prox groups, and it cleans that up. So it keeps it nice and procedural. You don't have to get in here and work with individual weights. And so you have a procedural system. So if this jacket changed or if anything changed, as long as those component tags exist, you're going to get a clean bind on your jacket. Okay, so that's all component tags. Let's get into fall off. So we kind of broke things into two sections, right? We have membership and we have weighting. So fall offs are addressing the weighting side of the equation. So what fall offs are, and this is going to probably sound a little technical, but they are networks, node networks that build up a weight function. And that weight function is passed off to the deformer, and the deformer evaluates it once it knows what geometry it has. And you don't really need to know anything about all that except to know that that means it's topology independent. It means these networks can be reused, and they're extremely efficient in that regard. So one type of fall off that you can build into a network is called a primitive fall off. And here's an example of what that looks like. So I want to make a belly jiggle. So I'll just create a cluster on this whole character. And so you'll see I'm affecting the entire character, but I want to isolate the effects of that to this rhinoceros's belly. So I go into this widget, I right click and I say, create a primitive fall off. And it's really small and seen right now, I'll scale it up, but it created a sphere, a little sphere primitive down here that now wherever that sphere intersects this character's skin, it's going to drive the weighting, and that's going to be evaluated by the deformer on this particular mesh. So if the mesh was changed out, or if a different deformer used it, they could still evaluate using this procedural fall off. So this one, I'm just going to shape it so we get a better shape. I should mention, I put some notes on here, but these assets were provided by Create 3D Characters. These are some awesome things by Andrew Silk and the team over there. So they've done some amazing things with it. So these are really cool characters to show this stuff off with. I'm excited to show it. So here's me just probably spending too much time shaping this to show you the different features. You can play with the fall off curve. There's kind of an inner bounds and an outer bounds. The dotted line shows the outer bounds. That's where the fall off ends. The inner bounds is white, is solid. So that shows where it starts. There was the weight visualization, so you could see how these things look. So that's the fall off. Now this is a bit of a blunt tool. So you can actually end up picking up parts of the character that you maybe didn't want to pick up. So I show an example of that where that belly is picking up part of the leg. So if I go and I manipulate this, you see the front leg is getting picked up. Well, we have another fall off that's called a blend fall off. And that's a great way to combine other types of fall off. So here we're going to use a blend fall off to combine two primitive fall offs. And you'll notice that the other fall off I have sitting under his nose right now is inside out. I flipped the start and the end. So it becomes negative. So when I move it over, it's going to carve away influence. So here it's coming in and it's carving away at the leg. So now we've taken this blunt tool and we've gotten really targeted weighting that's still procedural. We can subdivide or poly reduce this rhino to our heart's content, and it's still going to deform correctly. Then you go into the blend. You see there's different blending modes. I'm going to show some up here that'll be garbage like divide, but basically all these are putting out values from 0 to 1, and these are just like composition modes. You can just say what operation are we combining them with and play with them different ways. By default, I really like to stick with multiply, but there's a lot others here that you can play with. Okay, so this primitive fall off actually has two modes. It can also be a planar fall off. So I have another one of those that's the sphere at the back. You see his back legs in the effect, but maybe I don't want to carve out just the leg. Maybe I can be a little more blunt than that. So I'm going to take this other fall off here and I'm going to change this primitive fall off. It's the one that's already created, but I can go into the fall off type and I can change it from sphere mode to plane mode. So now you can see that as I bring that in, it starts carving away some of the effect of the back leg there. So you can see it kind of taking out the shin some. So now we've isolated this fall off. I don't know where we are in time. If somebody wants to let me know in the chat how we're doing on time. Okay, so we've seen blending of fall offs. We know this is a blended system. So what about weight painting? Okay, let's go there, right? So we have a type of fall off that is called a component fall off. And this is really just a weight table. Now, fall offs are meant to be topology independent, and weight tables are very topology dependent. You have a value for each individual component and each individual vert. But we've worked around that problem. So we do have this component fall off, which in and of itself is a weight table that is meant to be associated with a certain geometry. But we have other fall offs like a transfer fall off that can remap those on the fly through data flow to different topology. So what that means is if we have this fall off system for painting falls, I'll show you how we can create that. Here we have this deformer it's going to be a jaw. And so if I come into this cluster that represents the jaw, I'm going to assign a component fall off, which means, hey, I want to paint this fall off, right? So I'll right click on this and I can come down here and to paint this fall off. And it's your traditional painting interface that you would see if you're painting the weight on any cluster. So I'll set it to replace. I'll do my poor man's version of weighting on this. It's been a while since I've been in production, so I know y'all probably have much faster techniques that you use to get at these weights, but I'm just going to get a rough selection of the jaw. I'm going to flood it and I'm going to smooth it a bit just to get that jaw in there. I want to do a coarse grain deformation here to show you this effect. So here we go. We'll grab this thing, we'll paint it, pop open the paint tool, set the value to 1. We'll go ahead and flood that value so we affect the whole thing. I'll smooth it so it's not so rigid at the edge. Just kind of drill that down. And now when I open the jaw, you're going to see this jaw open with a fall off. But the corner of the mouth is pretty squared off, and I don't like that. But maybe I like my base level weighting and I don't want to go touch it. So instead of that, I can use a blend fall off and I can add another component fall off to this and I can layer them together, right? So there's a lot of people that really want layered workflows in here. So we have the ability to create this other fall off. We'll bring the second component fall off in here. This also could have been another layer within a single component fall off, which we're not talking about, but I'll try to cover that at another time. So now we'll select that other fall off, the second fall off, and I'm just going to paint out the corner of the mouth. And keep in mind that this fall off and the other fall off are compositing together. So here you'll see I'll just kind of knock some of that weight out. And this again is non-destructive. It sits on a separate layer. Smooth that out. So I've rounded that mouth a little bit. Now, if we go back to the blend fall off, I can turn the effect of this on and off because it's just a fall off in the blend. So all those can be disabled. So I like this shape a little better. Maybe your director may not, but I didn't spend much time on it. And you can see I turn it to no operation, and we can see we're toggling off that effect while still keeping the base layer there. So extremely effective way to incorporate layered weight painting onto this fall off system. And keep in mind, this blend fall off is agnostic. It'll take any fall off you want. And there's even a fall off API if you want to create your own fall offs that can be registered with this system and blended together. So very, very powerful system. Okay, so that's the basic gist of fall offs. Both component tags and fall offs go really deep, and I just don't have the time to go deep here. So hopefully later on Twitter or on some area blog posts, I'll be able to put out some more content for you to help you dive deeper into these tools, because there's a tremendous amount of things you can do. These are really just building blocks that you can combine together in all sorts of permutations to kind of land on the final result you want. They're not single purpose things. They're meant to be more general purpose and combined together to get different results. You can already imagine where you might be able to use a lot of tools we put out to replicate the soft mod with more flexibility using fall off. So just something you can think about there. So now let's talk about some new deformers that we've created. The Solidify deformer is a really cool deformer that saves a tremendous amount of time. And what it allows you to do, it allows you to work with layered weights in a way where you can create base layers and allow parts you don't care about to just shred. You don't care, like on this character, if I want to paint a muzzle control, I only care about the skin. I don't care about the horn. I don't care if the horn shreds on me when I'm painting the skin, but I do need to come back and I need to correct that horn. And that's where the Solidify comes in. You'll also notice that Solidify is going to be another creative use of component tags because it's going to act on a component tag. So here's the rhinoceros. I created this muzzle control. I know this is breaking anatomy, but a lot of directors will ask for something like this. And you'll see it shearing the horn. So I'm going to create this Solidify deformer, and I'm just going to give it the horn component tag. And you'll notice that the horn just corrects itself, right? It creates a rigid version of itself. It follows the skin. It blends into the skin nicely. You notice the back horn is still shearing. So I'm going to use an expression to add the back horn in here. Now the back horn's corrected. Right? If you think about the things you would need to do this on your own, you would have to create some sort of locator that is following the skin, that's building a coordinate system, that has some original state of your geometry held rigid, and then you'd have to set up a blend shape to blend back. Tons of stuff. This is GPU accelerated. It's super fast. If somebody added a third horn to this rhino, as long as that third horn had its own component tag, this deformer would start working on it, right? So you could have two variations of this rhino with the exact same rig. One has one horn, one has two. They have the same deformation chain, and you don't need to touch the deformation change. So really, really powerful tool. And like I said, one more use of component tags, how you can use those name selections. Next deformer I want to touch on is the morph deformer. So the morph deformer is just a straight up A to B morph. And there's several things that it brings to the table. One is it's GPU accelerated, which is fantastic because you can use this to blend in non-GPU accelerated deformers that you may have created in-house into GPU chains without blocking GPU evaluation. I want to touch on one thing. We made an improvement to GPU evaluation to support more design patterns. Used to, if you had what we call a fan-in design pattern, where you have multiple deformation chains that merge into a single deformation change, everything upstream of that branch would be blocked from being evaluated on the GPU. So we call that fan-in. Fan-in design pattern is no longer a blocker for GPU evaluation. And so using that along with this morph, if you have a CPU version of a deformer and your studio doesn't have support to upgrade that to a GPU deformer, you can use it. And then you can use this morph deformer, merge it in. And the fact that you created that fan design pattern won't block the rest of that chain from GPU evaluation. Now, it's not magically going to put your CPU deformation on the GPU, but it will allow more of the deformation chain that was already there to evaluate on the GPU. So it's a very powerful function in that way. Another thing that it does, it'll do partial deformation, and I'll show you that in a second. And it also has lots of spaces that you can work in, surface relative spaces. You can do absolute mode or additive mode to where it's either going to stomp on prior deformation chains or add to them. So I'll show you this. So here's a character that this is one mesh, and what you see at the top left is you see a single cluster that's just moving a jaw on a head. I unfortunately don't have this on loop. And then you see the hair, which is just kind of as a sign deformer on it. So if you're using a blend shape and you wanted to do a bunch of head targets with blend shapes, you could do that. And you could trim it down to be just the head. But there's a trick that a lot of riggers know on how to make that happen. And it involves reordering the vert table of the mesh itself, where what you do is, if you don't want to have all your head targets be the entire character and you just want it to be the head, you go back to your base mesh, you cut off the head, and then you recombine the mesh back together so that the head starts at index 0 of the vert table. And so then when you do a blend shape with something that's only the head, they align up and the blend shape works. But that breaks down if the character was a two-headed character, right? Because only one vertex can be at index 0. So it's a hack. It kind of works once, and it puts restrictions on your modeling pipeline. People have to change the way they work to make that happen. So it's not exactly the way we want you to work with it. So this morph is this A to B morph. Like I said, it provides this GPU legacy support for CPU deformer kind of effect, but it also does these partial deformers. And what you can see is, oh, sorry, I skipped on to the wrong one. What I'll show you here is in this chain, what you can see is this component match node. So what the component match node does is a morph is nothing more than a vertex lookup from one mesh to another, saying which vert in that vert table over there should I line up to, and it goes to that position. So what component match does is it builds an association. It's like a lookup table that lets you use an alternate lookup into that mesh. So we have the ability that these will be created for you under certain deformation modes, but you can use them for other meshes if you like. There's other tricks you can use for this. And there's the potential to generate these lookup tables in a different way. This is the only way we've currently done it, but you could potentially put different matching algorithms in there to get this. So that's how we've got the hair and the head working at the same time on this character. The other thing you'll notice is we're taking advantage of spaces. So this character is using a surface space. So this doesn't use transforms to build up a coordinate system. It's simply using the mesh to determine what space it's in. So you'll see this character, his head has a skin cluster on it and his head is tilted back. But you'll notice that when his jaw moves, this jaw motion, it's happening in the space of the tilted head. So there's a lot of spaces to play with. And like I said, this can be an absolute deformation, world space deformation, can be additive. There's things that you can play with to get. So it's a very robust deformer. It's a very single purpose deformer. And what it does is it carves out a use case for the blend shape deformer that people have been using the blend shape for, because it's way overkill for the blend shape, into this special purpose. And it lets us simplify the use cases of the blend shape and potentially lay the table for improvements there later, where we don't have to worry about people trying to do these workflows within the blend shape. Okay. And so now we start combining these things, right? We've talked about fall offs. Well, those primitive fall offs, they can be animated, right? So here's an example of an animated fall off, and I've combined it with the effects of a morph. So we have a head on the far left that has a jaw with lips sealed. We have a head on the far right with a jaw with lips open, and I'm morphing between the two. So I'm doing a sealed lip trick with animated fall-offs. So here's how you can see these. Like I said, these are building blocks. These are just common components you can put together to do more complex things. And here's one of the ones you can do. And then, like I said, we released proximity wrap last year with Maya 2020. And it had several modes to it. And one of the modes that shipped with it was called cluster mode. But there was no workflows built around it. And it was very difficult to wrap your head around how to build it or use it. What we've done now is we've put the workflows in. They're going to allow you to use that cluster mode. And what that cluster mode is, it lets the proximity wrap act like a skin cluster effectively. It kind of behaves. It works on matrices. So instead of on geometries, it'll work on matrices. So here, I'll show you what that looks like. So here's another ZooTools Create 3D character. I'll select the joints, got the skin. You go into bind skin, and it gives you an option of which node it's going to use to create it. You can switch to proximity wrap. You apply and close that, and this is all driven with proximity wrap. Now, when you look at this graph here, one thing I want you to notice is this table is using that component fall off. So it's using a weight table like we talked about. Instead of being painted, it was calculated by the skin cluster algorithm. And because we haven't changed the geometry, this component fall off could be plugged straight into the proximity wrap. but you notice it routes their transfer fall off. And the reason for that is if we change our geometry, this proximity wrap will continue to work. Now, obviously, if you change it from an octopus to a rhino, you're going to get garbage. But if you change it from octopus A to octopus B, or you tessellate, or you split a poly, you don't have to go in here and reskin this guy. This transfer fall off is going to handle the remapping through data flow for you. And so that brings me to the end of the rigging stuff. Like I said, this is very deep. There's a tremendous amount of things here. It's hard to cover in such a brief period of time. So I definitely want to engage with you all on Twitter. I want to engage with you on the area blogs and try to get some more examples in front of you to see what you can do. In the last few days, there's some very proactive people, or last day, I should say, some very proactive people who've already jumped on this and already doing some pretty cool things that I've seen posted to Twitter. So please come have a conversation with us and let's learn how to use these things. And we'll keep pushing things forward for procedural rigging. So with that, I'll probably be browsing the chat window and maybe answer some questions there. And then we'll have the Q&A at the end. In the meantime, I want to hand it off to Mark Tanner, who's our animation PO. He's got some really cool things to show you.
Thanks, Will. Great presentation on USD and rigging. I'll just share my screen here and turn on my sound. Everyone can see okay? Awesome. Okay, so animation. Give me one sec here. Okay, animation in Maya 2022. As Will said, I'm Mark Tanner. I'm the senior product owner of animation for Maya and Motion Builder. I've got 20 years experience in mostly games, some VFX, but I've been working in games and animation for many, many years, using our products, working at companies like Ubisoft, Microsoft, short stint in VFX at Digital Domain and Capcom and Electronic Arts, to name a few. So I'm excited to show you all our new features. But first, I'd like to introduce you to one of our newest team members on the Maya team, Meghna.
Hello, thanks, Mark. So I'm Meghna Gupte, Senior User Experience Designer for Maya. Previous work experience has been briefly in software, but worked for over a decade as an animator for companies like Sony ImageWorks, Weta Digital, Scanline VFX, and Double Negative.
Awesome. So today, unfortunately, our special guest, JD, Jean-Denis Haas, had a big project at ILM he's working on, but there is a great video of our conversation with him that we'll be showing after. He's the associate animation supervisor at ILM, as well as a teacher at Animation Mentor in his own Spongella animation workshops. He's got a great YouTube channel, so definitely check it out. He's been testing out all these new features in Maya, and here's a little video on some of the new features that we're going to be talking about today and getting his reactions about those features. First, we hit cache playback performance. I saw a note in the chat. Has there been any updates to animation performance and stability? This has been a huge focus for animation for the team this year. You'll see some great gains in cache playback and stability. We've got a new ghosting editor that also works with cache playback. We've also got the time editor, which also takes advantage of cache playback. So you'll see a theme here with all these new features. It's all about that runtime final frame quality speed. We've also got some updates to time slider bookmarks and some really great graph editor additions for both motion capture animation and keyframe animation. So we'll jump into our video with JD and Meg and I, and just talking about all the new features in Maya.
Hi, my name is JD, and I teach animation at the Academy of Art, Animation Mentor, and my own Spongella workshops. I also work at ILM, and I've been working for, let's say, 17, 18 years, and I use Maya ever since in school up until now. It's a great tool. I'm very excited to hear about those new features.
So JD, what is your experience with cache playback been like up until now? Obviously, you've seen these videos now and gotten a taste of it. What's your experience been like so far? Now
that I switched to cache playback, it's just generally anything that makes the scene faster. as you animate, it's just better. I don't see why you would not use cache playback. It's so much better. Anything that makes it real time or close to real time in animation is just the best.
That's a great point. One of the things we're trying to do is really sort of open up the black box of cache playback, at least for animators. So one of the things we're trying to do with these videos and some of the updates is to really show what animators can do themselves, to just sort of fine tune the cache playback settings themselves. And depending on their hardware and depending on the scene and what viewport settings they have, there's a lot of little tricks there that they can do to optimize their scene. With your students, JD, do you see them using the ghosting editor and these types of planning tools in Maya to plan out their shots when they get started? Or
when I see this, I think of two things. One, it's just because I draw with my dry erase marker for my space. I got two of these, like two colors for what it is and what I want it to be. But sometimes it's just really good to have it clearly in scene, also with an orbiting camera, just to have it in 3D space. I think that with the custom functions of the opacity, the colors, all that is great. I would highly recommend that students would try it.
The key here is we've got cache playback enabled. You can try this tool out. You can experiment with it. If you have access to motion capture data or a library of keyframe data, you can really play with things here. So we're really excited about performance gains we have here, and then some of the new features where you can apply different layers of animation and get new animation performances from multiple takes. You're familiar with this, and you might use this one a little bit when you're reviewing animations, or how do you use this one, JD?
To me, this is so convenient just because you have it in your scene, and the fact that you can grab any control with any animation and then reposition it, that to me is just the best. Because maybe it's my Swiss nature, but I like to be organized and to have it color coded and to know, this is still rough, this is more polished. Or if you give notes, right? If you do this in a teaching setting and you get a scene from a student, you can say, this works well, and then this needs more work, this is kind of rough, and you can change it for them. It's just a visual and just an overall organizational tool that I think is really great.
JD, I don't know how much motion capture you deal with, but we've added a bunch of new filters for dealing with motion capture in Maya. We're finding that more and more users are dealing with motion capture. Do you use much mocap in your workflows, or? Yes,
at work, which I'm not really allowed to talk too much about that. But they have their own ways of cleaning things up, and every now and then you get maybe like a scene that's a bit more raw. So definitely looking forward to implementing that. My last couple of shows are kind of spaceships. Don't use mocaps. It kind of depends what you work on. I'm about to test out a Rococo mocap suit, so cool. I am very excited about any tool that will help me in terms of peaks and jitters and cleanliness.
That's
so
great.
It's always an issue, like with jitter, especially feet, just for dampening and just also keeping completely locked. Just there's so much help you need once you go outside of just a raw performance take.
On the flip side of that, obviously we saw some great keyframe workflow additions to Autotangent, and the whole idea here is we want to make it easier for animators when you're going from a blocked in scene, and essentially the first time you hit Autotangent and really start the hard work with fine-tuning those curves in the graph editor. We've actually updated the math and the algorithm behind how the curves interpolate and how they behave when you move the keys closer or further away from each other. So how does that apply to what you do with your animators and your students and your own workflows?
I see quite a few students using that, and I think that new fine-tuning is going to help them a lot. I think it's definitely helpful at the very beginning to rough something out just to get it going, so you don't have to worry too much and spend all that time. It also depends on your workflow, right? Some people have not too many curves or not too many keys and rely a lot on curve manipulation, and some people just do every frame. So I mean, again, will depend on your workflow, but I would definitely use it. I see students use it for sure as an initial start. I think it's great, and especially the new tweaks are making it a lot better.
Yeah, that's exactly it. It's that starting point. The old math behind it wasn't giving you an appealing curve like right out of the start, which is causing a lot of extra time just sort of getting a normal auto tangent that you might expect as an animator. So you make a great point. It is the foundation. Of course, we have all the tools that we're are available to animators. You can break your tangents, you can weight your tangents, and really go nuts when you're fine tuning and polishing. But this should give you a good start and save you some time. All right. So special thanks to JD. First off, it was great talking to him. We'll hopefully have the full version of that video. It was about an hour long, talking about all the new features and what you can do with Maya and animation. Also, shout out to Rococo. They actually supply all the mocap for some of the performance, as you can see in the GIF in the bottom right. So big thanks to them for some of the mocap data. So let's get into the details here. So again, powerful animation tools is the focus here. In Maya 2022, our latest animation toolset update helps users animate faster with continued focus on high performance and efficient workflows. We'll jump into a bunch of those workflows in detail. Meg will actually present some of them as well. We've got a new ghosting editor, which allows users to see spacing over time, look at some of the arcs of their animations, and essentially plan their animations right inside the work viewport, all with cache playback enabled, so you get that runtime frame rate. We've got significant improvements, as you saw, to the time editor. The time editor didn't actually have capabilities for cache playback before now, so now that's enabled. And we've also got some great layering and additive animation workflows that we're going to show you within the time editor for editing mocap or keyframe libraries. And then finally, we also have the great keyframe workflows improvements to how auto tangent works. We've got 3 new auto tangents, which we'll jump into. So number one, cache playback. Again, I saw this in the chat. This is huge for animators. And so in Maya 2022, we've really sped up the performance for regular animation playback, but also for simulation and dynamics. And this was a continuation from Maya 2020, but also years prior. More and more studios are using cache playback in production, and we're getting a lot of great feedback. We're tackling hundreds of bugs and issues and improvements recently that go into the latest version of Maya. We've also got some investment in image plane and image sequence support, which is great if you're doing VFX work. And then I've already mentioned the dynamics, but really the essence of cache playback along with dynamics and simulations is that real-time playback, live scrubbing your animation, and not having to play blast to see animation on your final frame character. Previously, you'd have to play blast that or render it, which takes a lot of time. And when you're iterating animations and constantly going over each animation, that's integral. So all of the tools that we'll show today is based on cache playback. So please keep that in mind. We'll jump into some of the details here in the next video. So we've got our octopus scene here. It's running at about 7.5 frames a second, full viewport 2 settings, anti-aliasing, ambient occlusion, full textures, and the whole deal. So it's running fairly slow. I'm on a laptop. It's a decent laptop, but we really want to show off the power of cache playback. So what I'll do here is I will turn on cache playback. And while the cache actually builds, you'll see it in the timeline, it builds up. I'll show you my settings here. So I'm in evaluation cache, basically the default cache playback settings. And now that our cache is built up, we'll hit play again. And you can see already, just with the default settings, we're already just about at our target frame rate, which in this case is 24 frames a second for this shot. So right away, some significant, triple the frame rate, which is awesome. All the same settings. This looks really good in the viewport, and I can go ahead and animate and iterate with real-time speeds. So if we right-click on the playback controls and go to playback speed, you'll see that we're in real time. And that's going to match the actual target frame rate in your animation preferences, which is 24 frames a second. But if you really want to see how fast cache playback can go, you can switch to play every frame free. You can see how much Maya can actually handle here. So this is taking the scene all the way to 140 frames a second. So you can load more characters, more complexity, and switch to these settings if you really want to unleash cache playback. So a great demonstration of just how fast and how real time you can get your animations playing with these nice viewport 2 settings to see your final frame quality animation at real time speeds. So yeah, shout out to ZooTools and all the folks involved with some of these assets and great animation scenes to demo this stuff with. It's been a blast showing all this stuff. Really nice models and animations, so thank you. I'll hand it over to Meg. She's going to present some of the new features in the new ghosting editor.
Thanks, Mark. So yeah, we now have a new ghosting editor in Maya 2022. As you all might remember, we had one in 2020, but now we have a way improved interface. And now you can visualize your animation. There'll be snapshot of animations through the scene. And now you can manage how and what parts of the character you would like to visualize in the viewport. As you all have seen, the cache playback feature and ghosting editor takes full advantage of that, and which means support for deforming geometry. There is improved viewport to support and real-time playback. There's also a custom ghost display, and that will let you manage multiple ghosted objects in one place. There are certain preset modes for different workflows, and you can also control the color and opacity of your ghost. So I'll show you the next video where there will be all the features here. So we have an improved ghosting editor in Maya 2022. And let's take a look at this. So as you see, this is an animated octopus rig, and it's running in real time. I have my cache playback mode on here, and we also have bubbles in the scene. Now to go to ghosting editor, I head to visualize under animation. I click on open ghosting editor, and you see that we have an improved interface here. And this new ghosting editor is now designed in a way that brings all the features here in one place, and which means leading to a more optimized workflow. So in the earlier versions of Maya, you had to head to visualize and then either select one of these options here or go to the attribute editor and head to ghosting editor here, where you had all this information right here. And it wasn't very convenient. So now with this new ghosting editor, you can head directly here in this and change or use any mode you want to. So now with the bubble selected, I have the top node selected here, and I have the include hierarchy selected, which means I don't need to individually go here and select the geometry. Now, when I create ghosts from selection, you can see that ghosts are created on frames before the current frame and on every frame. As you also see that once we create ghosts, the geometry is included in the space out here. Which means, again, you don't need to keep going to the outliner back and forth. Now, as you see, we have these presets here. And since we have it set on ones, we see ghost on every frame. Now, if you want to see ghost every 2 frames, you click on this option. Whereas if you want to see ghost every 4 frames, you can click on this option. Now, if you want to see ghost before and after the current frame, you click on this mode. Whereas if you just want to see ghost after the current frame, you can choose this mode here. We also have a custom mode. So in the custom mode, we have these options for frame step, pre-frames, and post-frames. So frame step is essentially the spacing between ghosts. And pre-frames and post-frames are the number of ghosts you want to see before the current frame and after the current frame. So if I increase my step size to say 9, you can see how the spacing between the ghosts has increased. And similarly, if you see, I've increased the pre-frames to 4 and I've increased it my post-frames to 4. You can see how the number of frames before the current and after keep changing. You also see that we represent these ghosts from post frames and pre-frames with 2 colors. And if you head to the display options here, we have the pre-frame color and the post-frame color. And feel free to choose any color of your choice for the ghost after the current frame or ghost before the current frame. There's also an option for changing the near opacity and the far opacity of ghosts. So right now, the values are set to maximum, but I usually like keeping my far opacity to the minimum. And as you can see how this opacity of these ghosts is changing. It just gives like a better contrast in terms of visualizing your ghosts. There's also a custom mode here. And I really like this mode because in this, I can go to any frame I want to. And if I just click here on add current frame, you see that say frame 97 has been added here. And now when I create ghost from selected, you can see that ghosts have been created on this frame. So again, I can just go around this frame, click on add current frame, create ghost from selection, and as you see, ghosts have been created on these frames. Now you can unghost any selected geometry by just going on one of the geometry shapes here. And if I click on unghost selected, you see that the ghosts associated with this geometry have been deleted. And finally, you can also click on unghost all, and as you see, all your ghosts have been deleted. So that's about it for the ghosting editor.
All right, thanks, Meg. Next up, we'll jump to our time editor improvements. So in Maya 2022, animators can now set the time editor clips to be additive, allowing them to mix 2 different clips together to layer animation performances. Additionally, the time editor now supports cache playback, like I mentioned. So this allows animators to essentially hit play without needing to play blast when you're building complex scenes with multiple characters and multiple clips. Let's just jump into the video and we'll get into some of the details. So let's jump back into Maya here and take a look at some of the changes we've done to cache playback in regards to the time editor. So I'll turn cache playback on and play back my scene. You can see I'm around 40 frames a second before that cache playback builds up. Once cache playback kicks in and the cache is full, we're now at around 60 frames a second, which also happens to be our target frame rate for the scene. The scene is some motion capture data shot at 60 frames a second. So we're now hitting our target frame rate, which is great. When you have complex scenes, multiple characters in the time editor, you want to be playing back your animation at that target frame rate and really have those final frame quality representations of your characters while you animate and iterate on your scenes, the performances. So let's play around with these cache playback settings here. Right now we're playing at real time, which is the target frame rate for this actual scene, which again is 60 frames a second. We're going to change to playback every frame free and really see just how fast cache playback can perform. So as you can see, we're almost near double the frame rate when we go into the free mode, over 100 frames a second. So this really just shows the power of cache playback along with the time editor. So some really nice gains here in Maya 2022. So let's take a look at our new additive animation clips in the time editor. We still have our walk cycle here, but what I'm going to do is essentially loop out this walk cycle a few times to match this other clip that we brought in. This clip by itself is a character with just upper body motion acting hot. And we want to layer this animation on top of the walk cycle clip. So we're going to set this clip below to additive. And essentially what we get, simple performance of character acting hot. All right, so some great performance gains with the time editor. Shout out to Turbo Squid. They provided a bunch of other rigs like the Bat Sniper that you just saw. So thanks to them and everyone involved. Next up, we'll show off our time slider bookmarks. So you can use the time slider bookmarks to flag events on the time slider, drawing attention to moments in time for animation or for layout. Like JD said, bookmarks are useful in many different workflows when you work with events in time. But in Maya 2022, we've added even more controls. So we've added some new hotkeys like interactive move and scale using control drag, and move frames with bookmarks, which is control and double click. So essentially, instead of having to manually type in specific frames for your start and end, much like the time slider works, you can actually manually go in and drag those around. And you can also select controls with those bookmarks that are associated with a character or something animated in your shot. We'll take a look at that in the next video. So let's jump into Maya here. We've got a scene of a character walking through the scene with some motion capture of a stumble. I've added a few different bookmarks using the bookmark manager. You can see an idle bookmark for when the character's standing and idling. Then I've got this other section here, walk start, where the character starts walking. And then finally, I have the part where the character's stumbling, which might be the particular area I want to work on. So previously, you couldn't move these bookmarks around by clicking on them. And what we've added is using the control button, you'll see this crosshair pop up. I can actually move these bookmarks around if I want to adjust the timing. I can also go to the end of each bookmark and scale these out. Before this, in previous versions of Maya, you had to go in and actually type in new numbers and do a bit of math, which was time consuming and not ideal. So that's a nice addition to have when you're really fine tuning both your animation, but also the timings of these bookmarks. The next hotkey we've added is the ability to select the timeline along with the bookmark as well. So if you control double click, it'll actually select anything in your time slider to go along for the ride. So if I have this foot controller selected with some keys on it, and I double click, I can actually move this bookmark, and now all the keys associated with it go along for the ride, which is really nice, again, to retime some shots along with the keyframes and the bookmarks together. All right, and next up, we'll jump into our graph editor edition. So I'll hand it back to Meg to run you through this.
Sure. Graph editor additions. We have several improvements to the graph editor now in Maya 2022. And there are new filters we have like smooth filter, there's peak removal filter, resample filter, and that would help cleaning up, resampling, and smoothing animation curves. There are also 3 new auto tangent modes, which are auto ease, auto mix, and auto custom. And that's going to definitely help reduce the amount of time needed to craft your animation curve shapes, especially the first time you'll start spining your shot. So I'm going to walk you all through the new auto tangents, and then Mark will go over the animation filters.
So let's take a look at these in Maya. As you see, this is an already animated character out here. Now let's grab one of the controls, say the root control. And as you see here in the graph editor, which is where most of the animators spend their time polishing their performance after blocking their shot. So let's select, say for instance, their Y rotations. And as you see, this is a very typical animation curve. I have my buffer curves on. So let's see first what the existing auto tangents do. Now, if I select the keys here and I click on auto tangent, you can see that in relation to this buffer curve, the shape of the curve has changed drastically, and there is a very harsh entry into this point out here. So what animators had to do, they used to keep inserting keys here and adjusting the neighboring keys around to get a nicer ease into this point and ease out, thus spending more time and efforts. The new auto tangents will now address these issues and will give more appealing curve shapes and also as per animator needs. So let's take a look at each one of these. So I grab these keys here and now I click on Auto Ease. So as you see here, in relation to this buffer curve, the shape of the curve has not changed much in relation to this. And there is a very nice ease into this point and ease out. The next mode is Auto Mix. When I click on that, as you can see that it has medium influence in relation to its nearest neighbor, which is this, and the curve doesn't ease into this point as much as the previous mode. Finally, it is possible to control the shape of the curve by using Auto Custom and changing the coefficient value. To go to Auto Customs, you go to Tangents, Auto, and you can see that a new menu has been added here in Maya, where you can see all the other auto tangents. And here is Auto Custom, where you click on this, which opens up this box, and you can see this custom coefficient value, which ranges from -0.5 to 1. Now a value of -0.5, so I'm selecting these keys here, and if I click on Apply, you can see that the shape of the curve has changed, and this works pretty similar to the Auto Ease. Whereas a value of 0, if I click on Apply, this works pretty much close to the Auto Mix, and a value of 1 works similar to our default auto tangents. You can also play around with any of the values you want here, suiting your needs, and to adjust the shape of the curve, depending on what you'll want. You can also access the new auto tangents by right-clicking on the graph editor, and you can see that these options have also been added under this menu out here. So we do hope that the new auto tangents will be a time saver, will help give more appealing curves and lead to a more efficient workflow.
So let's jump into Maya here. We've got this motion capture performance here running at 60 frames a second with cache playback. We've got the smooth filter and the peak removal filter. So the first thing I've selected is I have this knee controller here, and you can see I've got some keys that are all peaked and messed up. So I'm going to use this peak removal filter on this first. So you can see it did a great job of removing those peaks that were here, essentially those jitters that you get quite often with motion capture. So let's try this knee here. We've got the classic Euler filter fix here on this one. You can see we've got some nice curves here now. This particular area, we've got quite a bit of bumpiness. We're going to apply the smooth filter, smooth that out. So let's grab one particular channel. You can see some jankiness here. We're going to use the peak removal filter. You see how nicely that cleans that curve up. There are a few bumps here and there. We're going to use peak removal on that one again. You see what a great job it does on those types of curves. We'll grab these hands, which quite often have a lot of jitter in them. You've got a bunch of things happening here. I'm just going to smooth those out with the smooth filter, peak removal filter. See my cache building up. It's a fairly long scene. It's 365 frames long at 60 frames a second. But we've cleaned up those hands, gotten rid of all those jitters, have some nice curves there to work with. All right, so thanks again to ZooTools and Turbo Squid, everybody involved. You can see some really powerful new tools that animators use all the time, constantly. So that's been the focus, along with cache playback for performance. Special thank you to Rococo again for partnering us with the motion library and the motion capture data used in all these examples. UTools, Turbo Squid, JD, go check out JD's channel, as well as Harvey Newman. So Harvey Newman is more on the game side, but he's got some tutorials out on his YouTube channel going through all these new features. He had a sneak peek. And then most importantly, thanks to the Maya 2022 dev team. Thanks everyone for your hard work and congratulations. Thanks everyone. I'll pass you over to Stephen for modeling, I believe.
Thanks, Mark. That was awesome. Thanks, Will. Let me share my screen real quick. Actually, you know what? I forgot to set the audio setting, which I am going to need. Okay, here we go. All right, so we're going to shift gears here and we're going to talk about modeling. So we've got another, say, 20, 25 minutes or so, and then we're going to open it up to Q&A, but there's a ton of stuff actually to talk about on the modeling front. So again, I've already introduced myself at the beginning, but if you came in late, my name is Stephen Rosell. I'm a product manager on the Maya team, and I just realized my video is not going, so here I am. I've been working on the Maya team for quite a while now, and working with Maya for quite a while now, and I've been working across Maya in different aspects, but I have a particular interest in modeling, so I'm going to cover that for the next bit. So we have some cool new stuff to show. One is just a really great new feature that's one of the most common feature requests we get on the modeling side over the last many years. And then something brand new to Maya called Create VR for Maya, which is a VR application, a fully immersive VR application for doing sketching and building up of geometry for kind of design and concepting. And I'll talk more about that. We'll get into some more granular features. There's a lot of kind of lower level, kind of nuts and bolts type features, I like to call them, on the modeling front, which we'll get into. So we'll start with Sweep Mesh. Sweep Mesh is a great new tool. It's a lot of fun to work with. I think for the modelers out there, you're really going to appreciate this. It's something that it has been needed in Maya for a while, and that is basically just a one-click solution for converting curves into geometry. So here you see I take a curve, convert it to geometry, and then I've got all these sliders, all these bells and whistles for controlling the output of that geometry. So you can change the profile, you can have it a circle or a square or a line or an arc. You could set this to be a wave pattern, or you can even do instances, or what we're calling elements, basically similar to mask, where you're repeating a pattern, in that case, spiraling to create a coil. You can create custom curves for the profile itself, either use the pre-built ones or the custom curves. So you can create things like architectural details and crown molding and get really, really fine control over the shape of that extrusion. So it's, again, one-click solution. It's one node that has all this stuff built into it. It's super intuitive. It's really, really fast to iterate on. You don't set a lot of options up front. You just click apply, and then you just start going to town, tweaking the options. It replaces the old legacy NURBS workflow. So the legacy NURBS workflow has been around for a while. It's still there. You can use it, but as a lot of modelers know, it can be a bit cumbersome for creating this kind of mesh in particular. One of the things was this NURBS tessellate node. Without going into too much details, it was really complicated and unintuitive and hard to use. So this no longer requires any of that. You're not using NURBS at all. You're just going directly to polygons, which is the more common use case. And like I mentioned before, you don't need profile curves. So you can actually just use some of these presets, which you see up here, like these preset shapes with a lot of procedural attributes associated with them. Performance is actually very good as well. It scales linearly. So you can create one sweep mesh, or you can create 100 and then have that node control all 100 of those. And it accepts multiple input curves. So you can have one node per curve, or you can have one shared node for all the curves so that they all be uniform and consistent. So it's pretty flexible in that regard. And the problems it's solving here really have to do with the quality and the results, not just the ease of use, but the actual quality of the results. So you can see here what would happen with some of the old NURBS workflows, where it just really didn't handle things very well. So one example is hard edges or corners or right angles, linear 1-degree curves. The old extrude tool just didn't know what to do with those, as you can see from this image, and also volume preservation. So when it comes to actually creating pipes, for instance, you want to have a uniform volume across that. You want proper edge orientation when you're doing the elbow bends. The old extrude tool just, again, didn't really handle that. The new sweep handles it quite well. It also handles density quite well, so it does a smart topology. So it only adds detail where you need it. And it's used for lots of different shapes. So I mentioned earlier on, this is kind of a Swiss Army knife type tool where you can just create all these different shapes. It's not just tubes, it's not just robes. It's pipes, it's spirals, it's coils, it's twisted cables, it's architectural detail, crown molding, corrugation, muscle shapes, hair cards, you name it, you can create all kinds of different things with this. So I'm going to do a demo now. I'm actually just going to let this play, but I want to do a quick plug to an artist that we collaborated with. His name is Roy Bennett. He created this awesome kind of sci-fi futuristic car garage scene, and he was kind enough to let us use it for the demonstration. So I want to give him a plug. You can go to roybennett.artstation.com if you want to check out his work. Really talented guy, avid Maya user, of course. So I'm going to pause my talking, and I'm going to let the video play. The new Sweep Mesh tool in Maya 2022 is a really versatile curve-based modeling tool. Basically, works with NURBS or Bezier curves, allows you to select curves and then just in one click, quickly create a mesh. So most common example would be, of course, tubes and wires. But you can create different shapes based on these different profile presets. So we have the ability to create rectangles with rounded corners. You can control things like the width and the height. Obviously, you can control things like the subdivisions along the length. But it also does a really good job of dealing with things like elbows and things like corners, which the old NURB surface tool just could not handle. So what you'll see here is we're creating a pipe, and it maintains the constant volume all the way through the length of the pipe, including the elbows. So it creates really nice elbows. So I could basically select these and extrude them and get essentially like what looks like an actual plumbing elbow in a pipe. Similarly here, we can take an edge around a shape and create kind of frames and architectural details. So something like crown molding. And you can customize that using a number of different methods. So you can use a simple polygon shape and then define that shape as your profile and the perimeter of the plane in this case, or it could be any arbitrary shape, but the perimeter will define the profile of that extruded or that swept path. Then you can go in and interactively adjust that. So as you change the shape of the profile input, that will change the shape of the actual sweep mesh. And you can also do this on top of other surfaces or on top of other geometry. So here we're basically taking some edge loops on the fender of this car. We're converting those to curves. We're just doing a quick combine to turn that into one curve. And then we're creating a sweep, which by default is just going to be a simple circle. We'll tweak the divisions here a little bit. And then we'll actually use another edge loop from another piece of geometry as the profile. So we're using one edge loop from one piece of geometry as a profile, another edge loop from another piece of geometry as the path, and we're basically able to construct geometry on geometry with sweep. So here's another example of that. We're basically taking the edge loop around the collar of this character, this piece of armor, and we're going to sweep that. And by default, we'll get a tube. We can switch that to a line or to an arc. We have these other cool pattern tools like wave. You can control the alignment, so you can basically say align to the left or to the right or to the top or the bottom, and then you can expand out from that. Here we're creating cycles in the wave, tweaking the amplitude, tweaking the orientation, and then now it looks like we basically have kind of a beveled extension of that piece of geometry. And then lastly, we can create instances or patterns. So we're using the distribution feature here to basically create instances of tubes or any profile shape, and then repeating that in a pattern, a circle or square or linear pattern. And then we're tweaking things like the twist, and the twist is going to give us coils basically. So a wound cable, something like you would see on a suspension bridge. And we can also change the taper. So the taper can just taper uniformly or linearly rather, or we can use this nice profile, this curve widget to define the taper. So as you can see, Sweep is a really versatile tool for creating lots of different shapes. All right, so moving on, we're going to talk about something completely different, and that is Create VR for Maya. You may have seen a couple of teaser videos by now showing this off. It's an immersive conceptual design tool application that is it's kind of like a sidecar application to Maya. So it doesn't actually ship or bundle with the installer for Maya. So what you have to do is actually go to the App Store, the Autodesk App Store, to download this. And once you install that, you get a plugin that will basically connect Maya to this application. And I'll just kind of talk over this. This is a video that was created by the lead designer on this project, Lena Lee. That's her there. Not only did she design the user interface and the UI associated with Create VR, but she created some amazing demos. She's a great concept artist as well. And this is showing her kind of in action, creating a concept from scratch, using a reference image as kind of a background. And these are basically just curves. She's dropping down curves, and then, you know, in an immersive kind of space, she's able to navigate around those curves, you know, that look like brush strokes, but they're actually represented as curves. She can move them, manipulate them after the fact. She creates them gesturally, but then kind of modifies them after that to kind of reform them and reshape them. But just to kind of go over some of the highlights, again, this is a sidecar application, so it doesn't load up, you know, directly in Maya. You do have to have a VR headset. You have to have something like a Vive or an Oculus. But you can also send stuff from Maya to Create VR. So through FBX, basically, you can export data geometry out of Maya, including curves, including NURBs, including polys or sub-D polys. And then those can be loaded into Create VR. And then vice versa, you can actually start from scratch in Create VR. You can create curves and geometry, and then you can send that back to Maya. So there are simple tools. I'll show a demo here in a second that actually shows the interface in action, but they're just simple curve and surface tools just built right into the heads-up display of the UI. And then, like I said, you can kind of explore the form, explore the shape while you're in VR, and then ultimately, you can end there if you want to and just generate images, or you can actually send that geometry back to Maya. So I'm going to play a quick video here that shows it in action. Once you download and install the app, it will basically piggyback on top of Maya 2020. So you'll get a menu is what I was trying to say, that will connect to Create VR. And then you go to town, basically. You start freeform drawing curves. So if you want to work in a more conceptual kind of gestural way, you can just start dropping down these curves. And then, like I said, you've got curve tools to then manipulate them. And she's showing a couple of different examples here with the dragon and the girl's head, but you can also do more hard surface type stuff as well as the freeform type stuff. We'll show some examples of that in a bit. But once you drop down your curves or your strokes, then you can start to manipulate them with other tools. So you've got these nice kind of pre-selection highlighting features built in, so you can easily see like where your subcomponents are. So, you know, unlike in Maya, you're not constantly having to convert back and forth between object type and component type. You actually kind of have the component type built in with this kind of pre-selection highlighting. You can use reference images, so you can create these images somewhere else, you know, in 2D, and then bring those in as equivalent of image planes that you would have like in Maya, and then start to build and construct geometry from that. So once you get your curves laid out, then you can actually generate geometry from the curves. So we've got, you know, basic extrusion and things like stitching and merging tools built into this. So here we're basically taking the gestural curves that were created and then extruding out, you know, the body of the camera in order to create the actual geometry of the shape. So you're constructing in this kind of VR space. Like I said, it's fully immersive, and you're basically just exploring with shape and form. And then you get these heads-up displays that pop up that allow you to access the different tools. And so you kind of just stay in this flow. You kind of just continue to work without being interrupted by like necessarily having to switch between tools, because a lot of the tools are kind of built into this kind of one workflow. So you could do things like extrude and stitch your edges and manipulate your edge loops and manipulate your vertices, all kind of in the same context. It's similar to bringing in reference images. You can bring in reference geometry as well. So here's a piece of geometry that could have been created in Maya, or it could have come from somewhere else. Through FBX, you can load that into Create VR, and then you can build on top of it. So you can snap your curves and snap your other objects on top of that. And then, like I mentioned, also it does support sub-Ds. So these are poly-based sub-Ds essentially. So you could create a cage in Maya and send it in, or you could just build the cage from scratch. And then you get these cool pre-selection kind of highlights of the sub-D edges, where you can then apply creasing and hard edges. So you can, by default, of course, have these rounded, smooth edges that you would expect with a sub-D, but you can crease that at any point at the vertex or the edge level. And then as far as manipulating, I already mentioned this, but you've got these cool pre-selection ways, highlights for your vertices and your edges. You've got quick menus that are associated with a controller. So you have your controllers, and then you can pop up these context-sensitive menus that allow you to quickly activate different features. And then ultimately, like I mentioned again, you can export this all back to Maya. So here's an example of a shape that was completely started from scratch in Create VR that was then ultimately exported into Maya for finaling or for rendering or for animation or whatever you're going to do with it. Again, you go to the App Store to download this. Actually, if you just go to the Autodesk App Store and just go to the Maya section, there's a little link for Maya at the top. This should be the top app that you'll see. And then, of course, there's full documentation that explains how to use it. That's really in depth and detailed. These are just a few examples of some things that can be created. Like I said, it's pretty wide range. You can create, hard surface objects. You can create more gestural kind of freeform objects. You can create realistic. You can create more cartoony. A pretty wide range of different types of objects you can create in here. So with that said, I'm going to go into some additional modeling improvements. And this is where we get into kind of some lower level, more granular things. There's a lot of little things that aren't necessarily related. Some are related, some aren't, but things that are useful from a modeling perspective. Now, this first one that we're going to talk about is targeted specifically for game asset artists, people who are building assets for games, and they want to see those kind of the budget count, the polygon budget count that they're going to deal with in Maya before they ever get to Unreal or to Unity. So it's called the Game Vertex Count HUD. HUD, for those of you that don't know, stands for Heads Up Display. It's just a quick way of saying it, but it basically gives you information in the viewport. So for this one, I'm going to also stop talking and just play a pre-recorded movie just to kind of walk you through how this works and why you would need it. In previous versions of Maya, it could be challenging for game artists to predictably meet their game asset budgets based on the vertex count in Maya, which is often used as a metric for game assets. So what you'll see here is the triangle set, or rather the vertex setting under the standard polycount heads-up display says that there are 20,000 in my scene. This is a couple of different meshes, but altogether this object is around 20,000 vertices, or so Maya says. However, when we take this into a game engine like Unreal or Unity, we're quite likely to get very different results. So we have created a game vertex count HUD that will give you a much more accurate representation of the vertex information. So what you can see here is that when I enable that, now my vertex count goes up to 41,000, a little over 41,000, from 20,000 to 41,000. So as you can see, the discrepancy can be quite dramatic. Now, in addition to that, we have also added evaluators for different game engines. So we have the default kind of simple evaluator, which is just general purpose. But if you're exporting to Unreal or Unity, we also have evaluators for both of these. And these will be slightly different based on a few settings, such as tangent mode, as well as some normal settings. This includes settings for MICT tangents for both. But if I apply this now, you can see that my Unity game vertex count is 34,000. If I switch this to Unreal and apply now, my game vertex count is very similar, but it adjusted slightly. So just depending on various subtleties with your geometry and the target engine, you will get different results. But either way, this will give you a much more accurate representation of your vertex count in order to budget your game assets. To make it a little more clear about what's actually going on here, I've set up a very simple example. You can see I've got a simple surface that is basically made up of 3 by 3 or essentially 9 faces, which equates in Maya to 16 vertices. So a vertice for every intersecting point you see here, which makes sense. However, depending on the geometry, this could change with different situations. So for instance, if I were going to grab this edge and convert this into a hard edge, what you'll notice is it actually splits the vertex normal at each of those locations and essentially doubles the vertex count. So now you can see that even though Maya is still seeing this as 16 physical vertices, the game vertex count is actually 20 because it's taking into account those split vertices. Another example would be with UV editing. So you'll see here I have a single UV shell. So if I take this larger shell and I scale it down a little bit, and I'll move it off to the side, and then I take a single face within this and I simply unitize that, which will basically separate that out into its own unique separate UV shell. As soon as I did that, what you can see is the vertex count went up again because of the UV borders. So the UV borders in conjunction with things like hard and soft edges can really have a big impact on the game vertex count that you should expect to see coming out of Maya. And again, with the game vertex count display, you can now get a much better approximation or calculation of what your vertex count is going to be when you send it to a game engine. So again, this was a real pain for game artists in the past because they'd have to actually send it to the engine to get any idea of what their actual count was. And now, of course, you can just do that on the front end in Maya a lot more easily without having to go back and forth. So we're going to talk about a few other kind of low-level changes. We've got a few related topics or a few related updates, I should say, around pivots and transforms. And it's not the most glamorous thing to talk about. I mean, pivots and transforms are kind of boring, frankly, but they're important because it's something you touch literally every day. So one example is interactive pivot snapping. So we introduced interactive pivot snapping where you can go into this interactive mode and snap to different points, but it was super limited because you could only snap to the points on the object you were working with. Now you can actually snap that interactive pivot to anything in your scene. So we've opened it up so that any object that's visible in your scene, you can align or snap to the vertices or the edges or the faces. You can control just the orientation or just the position and so on, all the stuff that you would expect, but now it's going to work with all of the different assets in your scene without having to constantly juggle your selections. So little change, but one of those things you do pretty frequently. Another update to transforms and pivots in particular is the bake pivot option. So in the past, when you went into interactive pivot mode and you edited that pivot, it would temporarily set the pivot. But if you went back to object mode, it would basically lose that offset. So now you can actually set it to bake. There's just a simple setting on the transform tools where if you rotate that pivot, for instance, it'll automatically bake that rotation of the pivot to the underlying transform under the hood so that you don't have to constantly go back and forth and reset it. So that's optional. You can turn it off if you don't need it, but oftentimes you obviously would. Another thing that we've updated is match transforms. So match transforms, it's been around for a while, but it used to be kind of an all or nothing proposition. You could match XYZ and that was it. Like you couldn't control the individual axes. Now you can match just X or just Y or just Z or some combination of them. So if you just need to match the height of a transform or you just need to match left to right or whatever. This is applicable to modeling, but also things like rigging. If you need to align things like controllers to a skeleton or something like that, you can obviously use it for non-modeling purposes. Another option that we've added for matching transforms is the bounding box scale match, which is super cool because it's a simple little thing, but it allows you to match the scale of an object independent of its actual transform values. So in a lot of cases, if you set scale to be 222, then it's not going to be the same for each object. I'll actually let this one play again, but as you can see here, each one of these has a different scale kind of relative value. So if you set them to 0.5 or 2, then they're not going to scale the same way. Here we can go into match scaling, set it to bounding box, and we can have these match the exact scale regardless of what their underlying scale values are. So again, little change, but super useful when you need it. This is something that has been kind of a long-running request on the modeling front, and that is the ability to add thickness to an object. So Max has been able to do this very well for a while, and we basically just needed to go in and rewrite some old code is what it boiled down to. So we went in and we basically rewrote the extrude thickness algorithm to allow it to work on a complete shell that is of complex kind of structure and shape. So what you can see here is in Maya 2020, if we extruded on an entire object, depending on the shape of that object, you'd get these wacky results. So it wasn't really easy to do and it would require a lot of fixing. Now in Maya 2022, it just works. So when you extrude on an entire object, just because you want to add a little bit of thickness to that object, now it extrudes in a very predictable, very uniform, very even way. So there's nothing you have to do. You don't have to change any settings. It just works now in a way that it didn't work before, as simple as that. But it's, again, this is one of those things that people are confronted with on a pretty regular basis when it comes to modeling. So one more improvement, actually we've got a couple more. Faster selection, basically. We've actually improved low-level selection kind of across the board, but it shows up particularly well around lasso select, which you use oftentimes when you're dealing with like scan data. So if you have really, really high resolution scan data in the millions of polys, you sometimes need to isolate parts of the geometry. So it's almost embarrassing to show this, but in Maya 2020, this actually took really long time to do. This is an almost, let's say, 7.5 billion poly mesh. You can see in 2020, it's still going, and I accelerated the time. So it actually took almost a minute to select the head on this object in Maya 2020. Again, not great. But in Maya 2022, that same exact scene, you select the head, and a second later, it's selecting. So this is what you would expect. Again, this is one of those cases where, we had old code that we basically just need to go in and refactor. So we went from, again, a minute down to about 1.5 seconds, so whatever that is, 45 times faster, if I did my math right. Target weld has improved to incorporate preserve UVs. So on the UV front, you've been able to preserve UVs when you manipulate a vertice or when you move edges around for a while. But there's some tools that just didn't support that, and target weld was one of those. So now when you target weld and you're stitching between like different shells, it'll actually merge those. It doesn't even have to be shells, but let's say a hole or something, and it will kind of recalibrate the UVs under the hood. So it will actually correct the UVs to avoid texture stretching or texture distortion, or at least minimize it as much as possible. And that's just a setting basically on the tool. On the UV front, also, we've made a few incremental improvements to the UV editor. So common request was, hey, we need feedback on the UV coordinates and be able to track those easily. So we added a UV heads-up display so you can actually see the UV values. And then also from an editing standpoint, when we introduced the UV toolkit, we actually lost the ability to directly edit the UV values. We've added that back in, so now you can go back in and you can select one UV and you can edit either U or V or both, or you can apply that to multiple UVs if you need to do like an alignment or if you needed to kind of copy and paste values around between UVs. So very low level, kind of simple change, but if you're doing UVing a lot, that's obviously gonna be a factor. And then lastly, we want to talk about some updates to the Paint Vertex Color tool. Again, this is kind of low level, but if you're using Vertex Color to store data, which is often done with game development, like oftentimes you'll use the RGB channels to store some sort of a game data that you would then use in game for some other purpose. You couldn't really visualize that before. So if you were going in and you were painting R on one part, red on one part and green on another part and blue on another part, you couldn't really tell because it would always show you RGB. Now, if you look below here in the display settings, we have channels R, G, and B, and we can toggle those on and off so that you can see exactly where your R is, exactly where your green is, and exactly where your blue is, so you know where that data lives and how it's applied. And then one last thing, it doesn't show up in the demo, but some people are using alpha also to store data. This is a simple channel. And so now we have the ability to represent that alpha as actual alpha, in other words, actual transparency, or you can toggle into this grayscale mode so that you can actually see it kind of as a grayscale value if you're using it for other purposes. So those are some nice, again, kind of low-level improvements, but if you're doing this kind of work, then obviously it's gonna have an impact. So that wraps up my last part of the presentation. We're done with the modeling stuff, but I know there've been a lot of questions along the way. We've been trying to track them as best we can. We answered some directly, but we also wanted to save some for kind of the live Q&A portion. So I'm actually going to stop screen sharing here because I need to go back and look at the chat so I can see if there are any modeling related questions. But in the meantime, I think we're going to start with Will. He'll answer some USD questions and some rigging questions. Pass that off to Mark. He'll answer some animation related questions, and we'll come back to me if there are any modeling related questions and wrap it up.
Yeah, thank you. So this is perfect. And like we mentioned at the beginning, we're all work from home. So there are some technical challenges that happen here and there. And we had one hit us, but fortunately we do have Paul from Luma Pictures on the call. And we wanted to bring him up at the tail end of the USD talk, but we've got him now. So we're going to take a few minutes before we get into the Q&A, and we're going to give Paul the floor and let Paul go ahead and talk. If you remember, I ended my USD presentation talking a bit about GitHub and about the collaboration among all the studios and all the contributions we're getting. And Paul has been a part of that. He's been part of Luma Pictures, which was a big contributor to the repository, particularly around Maya to Hydra, which is the plugin that allows the Hydra render delegate to work within Maya with the Maya scene delegate. So I'm going to hand it over to you, Paul. Thank you for joining us, and I think you should be able to share your screen now.
Okay, great. Thank you. So let me go ahead and do that. Share that. All right, and okay, thanks. So thanks for that intro. I guess my main punishment for having those problems is now I had to follow Steven's talk with those really cool VR stuff. So that's a bit of a hard act to follow, but do my best. I'm going to be talking about, yeah, as you mentioned, the sort of collaboration on open source on my USD. And as a developer, this is really exciting to me because it opens up a lot of new possibilities for collaboration and communication. And you know, just like in marriage, you know, communication is really important. And so if you're not a developer, it matters because it just means that we're going to be able to get you better, cooler tools faster. So just first of all, you know, I'm from Luma Pictures. So if you've haven't heard of us, we're sort of a smaller studio, but we're kind of growing into a mid-sized studio. We're a little over 250 people now, which is the biggest we've ever been. But if you don't know us, then hopefully you're recognizing some of these pretty pictures I show you from some of the cool projects we've worked on. But I'm not here to talk about these pretty pictures. I'm here to talk about USD, which I think is way cooler because I'm a nerd. But at Luma Pictures, we're all in on USD, and it's heavily integrated throughout our 3D pipeline. So that means, just as a baseline, we use it as our primary interchange format for pretty much all our assets. That means modeling, that means our shaders, our tracking, animation, almost all of our FX, those all go through USD. And it's also how we define our relationships. And by that, I mean which assets contain other assets, which shots have which assets, how things are laid out in 3D space, all those sort of relationships, that's all within USD. And at Luma, we actually also use it to track progress. So that means both within a given department. So we track versioning within a department. And we also use it to do gatekeeping between departments. So we use it to mark when a given anim is ready for use downstream by lighting, for instance, right? That's all done in USD. And we got in pretty early on the USD game at Luma. USD was first open sourced to the world by Pixar in late 2016, and we were able to get our first change incorporated by them in January 2017. So just a couple months later. So that also shows just how much we believe it's in getting in early on the right technologies. And also, you know, that we believe in the power and usefulness of open source. So when Autodesk announced that they were starting work on a new open source MyUSD plugin, we were really excited about that. And we jumped at the opportunity to collaborate with them. However, when I said that was a new plugin, that's definitely true. It is a new thing, but it's also sort of relative because MyUSD has a bit of a complicated lineage, and that created some unique challenges for collaboration. And so in order to sort of understand that, I'm going to have to give a bit of a quick history lesson on MyUSD. So in the beginning, Pixar created USD, and it was good. And then, sorry, I gotta drop that ridiculous voice. But USD was a really big project with a whole bunch of sub pieces and plugins. And just one of them was Pixar's original MyUSD plugin. Oh, sorry. If you heard that, that was my dog. Anyways, he's excited about the Pixar MyUSD plugin, but Analogic noticed that there were some big feature gaps in there. And so they created their own plugin and they split it off in its own repository, its own house for it to live in. And then companies like Luma came along and they were using one or both plugins, contributing back to them. Other companies came along, sort of did the same thing. Some would use one, some would use the other, but it was a bit of a complicated, confusing situation. So Autodesk came along and they really wanted to provide some clarity and some direction, reduce the confusion, simplify, create a single compiled binary, and really provide better direction. So, but given this sort of past baggage, it created a lot of challenges because there's a bunch of different repositories, there's multiple companies already using stuff, all with our own requirements. So there's a lot of potential there for friction. So in order to avoid that, we came up with sort of a multi-stage unification game plan. And the first stage was just really basic. We'll get everything in one place. So we want to get all the Pixar and Analogic code all living under one roof, hosted by Autodesk. And then, so that was basically just give equivalent of a copy paste followed by some basic unification of the build system. And that might not sound like much, but it's actually a really big milestone for the team. When we got all the core studios all using this Autodesk repo for all our own internal builds and everything. So once after we did that, the next step was Autodesk needed to create their own plugin. And the reason why they needed to do that is they needed the freedom to make changes and decisions that were different than potentially the decisions made by Pixar and Animal Logic. And the reason for that is, first of all, sometimes they just made conflicting decisions, right? And so, and the other is because they had a lot of opportunities to make something better. So they could just make better decisions because they had access to Maya at a lower level than we did. And so they weren't subject to the same limitations. And then on the same, the flip side is for the studios, that means that we could keep using the same plugins that we're used to in production without having to halt production or freeze anything or stop development, right? But if you're good with math, then you might have noticed that there's one problem, which is we went from 2 things to 3 things. And that's, if we're trying to simplify, that's the wrong direction. So the real key to this is that we wanted to try and consolidate stuff so that we created a shared core that all the plugins would use. And then over time, we started moving stuff out of the Pixar plugin, the Animal Logic plugin, into this shared core, right? And the idea there is then eventually, as the last step, that shared core would become big enough and contain almost everything, so that basically we would just eliminate the Pixar and Animal Logic plugins, and we're just left with this new Autodesk plugin. And I think the net result is that it actually ended up really working out pretty well. And we had a lot of really great collaboration. And Autodesk did a great job of providing direction and communicating and accommodating the needs of various studios involved with this development to make sure that you're all working towards the same shared common goal. And so in the end, we ended with a better product that fits everybody's needs. And so for Autodesk, that means they got to really maximize the integration. They ended up with a plugin which really is a lot nicer end experience for artists because of that solid integration. They weren't, as I said, confined by past decisions, but they could still actually benefit from the work already done. And they got a really solid out-of-the-box tool set. But then for the partner studios like us, what we got is that we could keep using the things we're used to in production. We could still, while doing that, share development with the common, team towards that common goal. And we had, great customization for our own studio's needs. And that's not just because we had access to the source code, though that obviously is big. It is also because Autodesk really made that a priority. And they gave us a lot of the hooks and the API access that we needed in order to make things really mesh with our individual studios' pipelines. So in all, it's been a really great team that I really enjoyed working with, and it's been a privilege to work with these companies and the people at them. So thank you, first of all, to all of you, the teams and companies we worked with, and thank you to you guys on the audience for your time, and lastly, thanks to Marvel for letting us use these fun images. All right, so I think then that's back to Will or Jennifer, I'm not sure, but and the Q&A.
Yeah, absolutely. Thank you, Paul. That was awesome. Yeah, we couldn't have done all this USD work without our collaborators, and Luma, Animal Logic, Pixar, Blue Sky. They've just been invaluable partners. And then there's many more studios who've jumped in through other programs we have and contributed to open source. So it is absolutely been huge. So just like we have too much content to fit in this, we have too many questions to hit them all here. So I'm going to take a question that seems to be common here about USD and one about rigging. And then I think that there may be some forums where we'll try to target some of these in some blog posts and other content later, trying to hit the questions. We have all these as a list, and we'll keep those questions and try to address them. It's really good to know where the gaps are in your understanding around this. So thank you for all these questions. So one of the questions I'm seeing is about interacting with data in USD and supported mel commands, and how the commands are supported, or can you edit USD data directly? One thing that's great about having USD data in memory is it is completely USD data in memory, and the the Pixar Python USD API is fully accessible right inside Maya's script editor, and you can work on that data, and all the Maya UI is just going to sync with that state. We don't keep any state of the data outside of the USD data model itself. So that is the ground truth. So when you act on it with the Python API, it will update Maya, and it's not a sync because there's only one data model. And then as far as implementation of commands, we do have things like the parent command, the rename command, things like that have been made UFE aware, which are those API that we use to interface with USD. Not all Maya commands have been UFE aware and work on USD data, but as we expand the workflows and we keep pushing, we'll look at what native commands need to support this other data model. And again, it's through UFE. So we're not teaching this how to work with USD data. We're teaching it how to work with a non-native or a non-Maya data model, which means that other data models could be introduced and use these same APIs. So that's really great. With the rigging, I'm seeing a lot of questions around legacy workflows and legacy functionality and how it blends. And I wanted to touch on the fall off system. And one thing that I really didn't go into, and again, there's a lot of uses here, and we just scratched the surface. It wasn't stretching the content. It was barely squeezing it in. So with this fall off system, sometimes you have legacy weights like waitlist, traditional waitlist, and you want to get those into a fall off system. That's another thing the component fall off can be used for. You can pull waitlists out of nodes and push them into component fall offs. And now you've taken something that is a topology dependent waitlist and you've moved it into a topology independent fall off system, which can now be used elsewhere on different deformers and on different geometries as well. And then there's the inverse of that. To get out of the fall off system and back into legacy workflows, we actually have something called a fall off eval, which will take a geometry as an input and a fall off system as an input. It'll evaluate the weights and it'll output a wait list. And then that wait list can be driven into any deformers that don't yet have support for the fall off system. A good example of that is you can use it on per target blend shape. So currently the blend shape, the global envelope is fall off friendly, but the individual targets are not fall off friendly. They don't accept fall offs on individual targets, but you can use that eval fall off, turn a fall off system into a wait list, and then drive that wait list into per target. So you can still get the fall offs to work on them. It just requires that translation layer. So that lets you round trip in and out of the fall off system in a really clever way. So those are the two questions I'm going to handle for USD and rigging for now. I'm happy to answer more later on Twitter and elsewhere, and hopefully we can get some blog posts for you. And I'll pass it on to Mark to maybe handle your questions.
Awesome, thanks, Will. So, so for animation, the biggest topic I saw was actually a couple of things. So a lot of people asking about, do I animate in Motion Builder or do I animate in Maya? And so the reason we've got some of these features actually from Motion Builder into Maya is because for the majority of people dealing with the final part of animation and fine tuning and plussing mocap, they want to do that in Maya and not have to go back and forth. So you're going to see more and more of these workflows come into Maya in the future. And the key to that, again, with my presentation is cache playback and those runtime speeds that you can actually get in Motion Builder, 60 frames a second and whatnot. So that is our focus, is performance and runtime speed, getting some of those things like potentially takes into Maya down the road. And there's a place for both of those packages. The motion capture solving and capturing is all going to stay in Motion Builder, and we'll continue to support that. But for animators that are actually dealing with the data and fine tuning it and manipulating it, more and more people are inside of Maya. They're still in Motion Builder, but more and more are going into Maya, especially with VFX and film. The second question really quickly was, what were my specs for animation performance and cache playback? So this whole demo was on a laptop. I've got an i7 Lenovo Intel 6-core processor with 64 megs of RAM with an RTX 5000 Quattro card from NVIDIA. That said, there's a lot of settings in cache playback that you can tweak to get different playback based on how much RAM you have, based on how your character is rigged, based on your viewport settings, based on the complexity of your shot. So go to that cache playback icon, right click on it, play around with the different settings, and get into the options and talk to your TDs, your riggers, and work together to get the most out of your shots, because not every scene is the same when it comes to animation. I think that's all the time we have for animation. A lot of questions will be answered on the forums and whatnot. So we'll be following up on all the questions that were asked today. So Stephen, do you have some modeling?
Yeah, I got a few questions. A couple of questions around Create VR and whether you can use some of these tools without being in VR, if you could just use them right in Maya. And the answer is no, although we're getting a lot of feedback that these tools are super intuitive and it would be great to have them in Maya. So it's something we'll definitely look at. But yeah, you do have to be like in a headset. People are asking about headset support. It supports both HTC Vive as well as Oculus. I actually have a Quest 2 that I just got that I'm going to test out. That's supported, but if you go to the download section on where you get the app on the App Store, it'll actually have a list of the hardware qualifications. I got a couple of questions around sweep. One that stands out is, can you use sweep with construction history for rigging purposes? And we didn't actually intend sweep to be a rigging related tool, but we actually have people who are exploring it. I mean, it's really meant to be a modeling tool, but we do have situations, like one example I can think of where somebody actually used NCloth to drive a NURBS curve, which was then generating a sweep mesh, and then that sweep mesh was a prox wrap deformer for another mesh, and it was used for animation. It was kind of this cool workflow, not something we necessarily planned for, but something some people are experimenting with. And then the last question, I know we're getting short on time. Somebody asked if the Game Vertex HUD, the Game Vertex Count HUD is customizable. And the answer is twofold. One is currently no, it's just a precompiled plugin, but we are looking at making that source code available as a dev kit example so that you would be able to go in, like if you have your own proprietary engine, and you would be able to write your own version of the game HUD, the Game Vertex HUD. We weren't able to get that through for a couple of, without getting into details, we weren't able to get that available, in 2022, but it's definitely something we're going to consider in the future, making that customizable. And yeah, I think the only other question that popped up was, can you use Bezier curves as the sweep path and or profile? And yes, Bezier curves are fully supported, so you can get these really very finely controlled shapes for both your paths and your profiles for sweep. So that's it for me. And I guess we've come to the end.
Great. So before we close off, I'd like to remind everyone that Bifrost had some major updates this past December. If you're interested in learning more about Bifrost, head over to our revamped Bifrost hub, where you'll find tons of tutorials, masterclasses, and blog posts. So be sure to check it out on the link on screen. I'd also like to introduce you to our new USD hub, where you can find all things USD at Autodesk, including past sessions, blog posts, and articles. And those of you who have burning USD questions, we are hosting an Ask Me Anything on Twitter on March 31st. So be sure to head over to Maya's Twitter account to participate. I also want to remind all you new grads and freelancers about Maya for indie users, a more affordable option for those of you working on a tighter budget. You can read all the eligibility requirements at the link on screen. Lastly, I want to give a big shout out to Maya artist Amaru Zis for allowing us to use his breathtaking artwork on this webinar. Thank you all for taking the time out of your busy day to join us. We hope you enjoyed the webinar and would love to see you on our Facebook and Twitter channels, where we'll post the webinar shortly. From our team to yours, we hope you and your families are safe. Thank you.
Thanks, everyone.